Hello everyone, my name is Ajit Singh Raina, a Docker captain and ARM innovator. I want you to join me at OSCONF this weekend on 10th of October. OSCONF is an open event run by a Collabnix community members to connect with all the leading Meetup communities as well as DevOps engineer. So this time we are bringing all the leading Jaipur communities together and we are quite excited about it. So this Saturday, I am going to talk about quantifying your world with AI, Docker, and edge devices like Jets and Nano. So mark your calendar and I look forward to see you all. Thank you.
I'm going to attend the OS conference that is happening for the first time in Jaipur, and I'm super excited for it.
So come up and join us for Open Source Community Conference 2020 Jaipur.
We have an interest.
Hello everyone, my name is Ajit Singh Raina, a Docker captain and ARM innovator. I want you to join me at OSCONF this weekend on 10th of October. OSCONF is an open event run by a Collabnix community members to connect with all the leading Meetup communities, evangelists, as well as DevOps engineer. So this time we are bringing all the leading Jaipur communities together and we are quite excited about it. So this Saturday, I am going to talk about quantifying your world with AI, Docker, and edge devices like Jets and Nano. So mark your calendar and I look forward to see you all. Thank you.
I'm going to attend the OS conference that is happening for the first time in Jaipur, and I'm super excited for it.
So come up and join us for Open Source Community Conference 2020 Jaipur.
Hello everyone, my name is Ajit Singh Raina, a Docker captain and ARM innovator. I want you to join me at OSCONF this weekend on 10th of October. OSCONF is an open event run by a Collabnix community members to connect with all the leading Meetup communities, evangelists, as well as DevOps engineer. So this time we are bringing all the leading Jaipur communities together and we are quite excited about it. So this Saturday, I am going to talk about quantifying your world with AI, Docker, and edge devices like Jets and Nano. So mark your calendar and I look forward to see you all. Thank you.
I'm going to attend the OS conference that is happening for the first time in Jaipur, and I'm super excited for it.
So come up and join us for Open Source Community Conference 2020 Jaipur.
Hello everyone, my name is Ajit Singh Raina, a Docker captain and ARM innovator. I want you to join me at OSCONF this weekend on 10th of October. OSCONF is an open event run by a Collabnix community members to connect with all the leading Meetup communities, evangelists, as well as DevOps engineer. So this time we are bringing all the leading Jaipur communities together and we are quite excited about it. So this Saturday, I am going to talk about quantifying your world with AI, Docker, and edge devices like Jets and Nano. So mark your calendar and I look forward to see you all. Thank you.
I'm going to attend the OS conference that is happening for the first time in Jaipur, and I'm super excited for it.
So come up and join us for Open Source Community Conference 2020 Jaipur.
Hey, hello everyone. Am I audible? Please confirm. Hello.
Yes, please go ahead.
Yeah, okay. So, hello everyone. A very good morning, good afternoon, and good evening from wherever you are across the globe. Thank you for joining us today for OSCONF Jaipur 2020 live. I'm Harshita Gupta. I'm currently an undergraduate student. I'll be your host for the time being. So, before we begin, let me express my gratitude for everyone on the call, my speakers, organizers, and my dear friends across the globe. Thank you all for your support who helped us shaping this event today, despite of the challenges which we are facing during the COVID-19 pandemic. So OSCON 2020 is a platform to connect and bring all leading tech communities, cloud native experts, evangelists, DevOps, and developers together under one roof. So you all will get a chance to interact live with the speakers. You can all can ask your questions and get the knowledge from our international speakers. So few points for you all is that any questions from the audience side should be posted on YouTube live chat section. There are volunteers who will help you addressing your questions, and as respecting the time, we shall address few questions. And make sure you respect speakers, your fellow members, and maintain code of conduct in the chat section. With that, I would like to welcome Ajit Singh Rana, a Docker captain and Docker community leader for Docker Bangalore, the largest Docker meetup in the world with nearly 12,000 plus members. He's also an ARM innovator. He is a prolific blogger and have over 230 plus blogs around Docker, Kubernetes, and cloud. His personal blog attracts roughly 14 million visitors per year. He runs the Collabnix Slack, which holds 4,700 plus community members today. Currently, he is working in Redis Labs as Developers Relation Manager. Earlier this year, he bagged the Docker Community Award by Docker Inc. during the DockerCon. Last year, he was recognized by his fellow captains to receive the Tip of the Captain Hat Award for the tireless dedication to sharing his expertise with the broader tech community. So you all can keep up with him by following him on Twitter, GitHub, and or his personal blog. So I'll share you the links on the chat section. So stay tuned. Now, with that, a warm welcome to Ajit Singh Rana. Over to you, Ajit.
Thank you, Harshita. Can you hear me?
Yes.
Okay. First of all, good morning, everyone. I'm really excited to be here. Thank you so much for being here, joining us for 5th OSCONF. And this is happening with the collaboration with Jaipur communities there are the leading communities in Jaipur around Docker, Kubernetes, and DevOps. And I'm really excited. I'm sure we are going to have a great day today. By the way, there has been there will be a plenty of talks, exciting talks from the industry experts and industry experts all across the globe. So stay tuned. Okay, so let me start with few of the very exciting statistics around cloud native development report. So as per the latest CNCF report, if you see, there has been a tremendous growth in cloud native developers. You can see on the screen around 6.5 million cloud developers exist across the globe, which is really the overwhelming statistic. And out of that, 2.7 million developers are using Kubernetes. Kubernetes today is changing the way how the DevOps works. Kubernetes is one technology along with the Docker, which is bringing a lot of changes, a lot of improvement in the way how we build a code till the way how we put it in the production. And if you look at another interesting statistic is 9 out of 10 developers are using container orchestration tools, which are aware of Kubernetes. Today, as a developer, you really don't have to go ahead and learn about the YAML file. You just go ahead with a continuous integration, continuous deployment model where now we have a continuous delivery model where you can go ahead and, as a developer, you just have to concentrate on your code and the rest of the things will be automatically taken care. So this is the latest trend, and that has affected DevOps in such a way that we do see a lot of collaboration, the ability to problem solving, how you go ahead and talk to the different teams inside the organization, and that has affected DevOps as a completely a different kind of a culture, right? Where the developers and operations works together to build a robust product. And if you look at the latest Atlassian report, where you can see that the foremost and one of the top reason or the most important traits for any DevOps teams has been in collaboration. And that is one of the reason why we are here today, collaborating with each other, coming up with different topics around Docker, Kubernetes, serverless platform, and then trying to go ahead and share our experience with you all. So with all the collaboration, this is our fifth OSCONF event which we are doing it. Okay, so the first one is started in the month of April in Bangalore. Then we did one in Pune, Kochi, Hyderabad, and then most probably these are the events which have attracted more than around 80 plus speakers, around 50 plus organizer committee all across India. And then most probably, if you see here, right, so we have been in one way, we have been bringing all of these communities together to basically form a kind of a team, right, and then help each other to grow in a DevOps world. First of all, I would like to go ahead and thank all our sponsors. These are the sponsors coming up from Jaipur community, and they have been quite supportive in each and everything which we do. They have, if you go to their respective Meetup pages, you can see about OSCONF. If you have any queries, you can reach out to the local committee members. So thank you so much for being part of this journey. A big shout out to our organizers. They have done a tremendous work in bringing all the events together, especially reaching out to speakers and then trying to find out the way how we can share our knowledge. And these are the young engineers, right, who have been part of this journey with not much experience, but they have been doing a tremendous job in bringing the community together. Thank you so much. If you look at the statistic around Slack today, we have seen an amazing growth in the last 1 year. If you go back to October 2018, we were just like 50 plus members, right? And today we are close to around 5,000. We will be reaching 5,000 in next 1 month. And the reason the numbers are very important for us, because we have a lot of exciting channels which can help DevOps engineers. Even if you want to go ahead and search for a job, we have a DevOps job seekers group where you can go ahead and try to search for your desired job. And what I have seen in the past 1 year is there are a lot of people are coming together to go ahead and contribute for these all technologies. We have around 6 to 7 repositories which are quite popular and been appreciated even by the newsletter like Cube Weekly and the InfoWorld. We have seen those repositories been highlighted in such a big forum. So it's proud to be a part of this community, right? And we will see how we can go ahead and reach out to more and more audience. And before I end up this keynote, one other thing which I want to really share with you and want to tell you is like the secret of living is giving, right? So it's not important that you be with the community, but you need to contribute to the community. So whatever you learn today, if you go ahead and give back to the community, especially in this pandemic situation where everyone is looking at the ways how they can go and they can grow their skill set, right? So do share your experience to help each other. It will always, you will get it back in a different way, but it is very important to collaborate and contribute at the same time. And with this, I end up my keynote. Thank you everyone for being with us, and definitely there will be a lot of exciting talks which will be happening today. So stay with us and enjoy the show. Thank you.
Thank you, Ajit. That was really a wonderful keynote. So with that, we shall begin with our first speaker, Mr. Piyush Gupta. Piyush is a cloud enthusiast with 5+ years of experience in developing cloud platforms and helping customers migrate their legacy application to cloud. He is also a public speaker and serves the developer community as part of Kubernetes Contributor Experience Group. He's currently working with DigitalOcean as Senior Developer Advocate. So, with that, a warm welcome to Piyush Gupta. Over to you, Piyush.
Right. Thanks, Ashita.
Yeah.
Let me just get my screen up. Right. I hope you guys can see the screen now.
Yeah, we are good to go.
Thanks. Good morning, everybody. And thank you for making time on a Saturday morning. Right. Happy to have you here. My name is Piyush Gupta, and today I will be talking to you about extending Kubernetes. Right. Uh, just a quick introduction. I work as a senior developer advocate with DigitalOcean. In my previous avatar, I have worked as a developer where I created platforms based on cloud native technologies and also helped customers migrate their workloads from legacy infrastructure to cloud-based infrastructure. I'm an active contributor to Kubernetes Sec Contribex project. You can find me on Kubernetes Slack. My handle there is Penso91, and you can also find me on uh, Twitter with the same handle. And if you are the kind of person who would rather write down an email, please feel free to send one at pgupta@digitalocean.com. So that's going to be the agenda for today. I will talk a bit about the difference between configuration and extension, and we will take a look about various ways where you can extend Kubernetes. We will talk a bit about CRDs and aggregated APIs. These are one of the two core ways that are usually used to extend Kubernetes. We'll take a look at operators, and I will have a short demo just to show you how CRDs work, and then we'll just take a look at service catalog. And if you stay till the end of presentation, there's a bonus for you as well. Right. So Ajit talked about Kubernetes, and how everybody is using Kubernetes nowadays, how everybody is containerizing their applications, and Kubernetes is brilliant, to be frank, right? I've been working with the platform for a couple of years now, and it provides you a lot of capabilities, right? You get auto healing out of the box, you get high availability, you get declarative APIs. What else? It increases efficiency. It can run your workload in a pretty efficient manner. It can help you increase productivity. It can help you make CI/CD pipelines more effective, right? And there are lots of good things about Kubernetes, right? But the question that we need to answer is that enough, right? And is that enough for your workload? Is that enough for what you are trying to do? Or is that enough for your for your use case, or for what you're trying to achieve for your environment, right? And sometimes the answer is no, right? No matter how good Kubernetes is, no matter what all capabilities it provides, sometimes it just doesn't suit your environment, right? And what do you do in that case, right? And that's where the extension of Kubernetes comes into the picture, right? And why would you want to extend Kubernetes, right? I mean, it is such an amazing product. It has all these amazing capabilities, right? And I've just listed down few of the pointers why people usually choose to extend Kubernetes, right? And one of the biggest use cases when you want to store additional information, right? uh, Kubernetes resource endpoints are usually the place, or these are basically the endpoints that store objects, right? Kubernetes has a lot of primitive resources, like pods, replica sets, deployments, daemon sets, config maps, secrets, and all of these, right? And they store a certain information about a certain resource, right? What if you want to store something additional? What if you want to store, let's say, you know, that's not given by Kubernetes standard or default installation, right? And in Kubernetes world, every resource is controlled by a controller. So, excuse me, I'm just feeling a bit under the weather, right? So, every single resource is controlled by a controller, be it a pod, be it a replica set, be it a deployment, right? Uh, what if you want to run your own controller, right? What if you want it to take action according to your environment, right? And again, one of the most used use case is what if you are running your legacy systems, right? As Ajit mentioned, everybody is trying to containerize their applications, their workloads, right? But sometimes you are not yet ready for that kind of investment, right? You have been running your applications, you have been running your workloads in a legacy system, probably with virtual machines and databases and all those things, and you are not yet ready to containerize them, but you still want to use Kubernetes capabilities, right? Extending Kubernetes and integrating it with your legacy systems is one of the biggest use cases of extending Kubernetes, right? And again, if you want to add new features, I mean, Kubernetes has more than 50,000 contributors, one of the biggest open source project on GitHub. And if you want to make some changes to the core of Kubernetes, I mean, it's pretty difficult. I mean, the PRs usually take months to go through, right? And before that, you have a CAP process, right? That's called Kubernetes extension proposal, right? And you have to send, you have to make sure that KEP is signed off by multiple SIGs and multiple maintainers, and then the PR takes time, and it might not be worth the effort all the time, right? You can probably just figure out a way to solve your use case by just extending the Kubernetes, right? So I want to take some time to distinguish between what configuration means and what extension means, right? So as I said, Kubernetes is you know huge beast, right? And it's not always you need to it's not always that you have to extend it or you have to add new features to it, right? All the Kubernetes components, right? Be it kubelet, be it API server, a controller manager, or scheduler, right? They have a lot of capabilities, and most of these capabilities are not enabled by default in a standard installation, right? And you can probably enable those capabilities by just adding a flag to these services, right? This is usually done by cluster administrator, right? And Kubernetes is a highly changing project, right? Highly evolving project. They have four releases in a year, right? I guess that's one per quarter, right? So there are a lot of features that keep moving from alpha to beta to stable, right? And these things might change in future, right? And they might also require a restart of services, right? Let's say if you want to enable a flag in kubelet, or you want to enable a flag in API server, right? You can enable that, but that might require some uh, some restart, or probably some extra configuration on the administrator part as well. Now contrast that with extension, right? The extension is basically a software component that runs independently, and it integrates deeply with Kubernetes, right? So it's not something that you are changing within the Kubernetes itself. It's not something, or it's not a capability that you are enabling within your Kubernetes installation. It's something that is running separately, and you are just integrating it with your Kubernetes cluster, right? And it can help you to support new types, and it can help you to run your own controllers. It can help you to take actions on those resources accordingly, right? So if you contrast these two things with configuration and extension, what it boils down to is configuration lets you use additional capabilities that already exist in your cluster. Extension lets you run independent programs, and it can just let you integrate with your existing cluster, right? Now let's talk about what all extension type Kubernetes has, right? And Kubernetes is a fairly extensible product, right? I mean, you can virtually extend each each and any component at any level, right? And if you look at the diagram, and if you start from the top, right, you've got kubectl, and kubectl is your command line client that you use to talk to the Kubernetes, right? You can extend kubectl by creating plugins, right? And there are a lot of plugins available in the market for kubectl. I mean, you can call it kubectl or kube control, depending on uh, how you want to call it out. But in the end of the day, you can create extensions for kubectl that can help you get the output in a better way, right? I mean, kubectl already creates a wrapper on top of Kubernetes APIs, but you can also create another plugins that can modify the output, or that can give you the output in a way that you want, right? Then you have got the API server, and API server is the core for the Kubernetes cluster, right? And when I talk about extending API server, right, you can basically run your own API server, right? And we will talk about extending API server in our aggregated API section. But the idea is you don't have to rely on the API server that is coming with your standard installation, right? And uh, as I said, right, API server is the core of your cluster. All the authentication, every component talk to API server, all the authentication, all the admission, everything happens via API server. But there might be cases when it's not enough, right? You might want to create your own authentication mechanisms. You might want to create your own admission mechanisms, right? And for that, you might want to run your own API server, right? And you can do that as well, right? And then you can extend resources, right? That we will talk about that in the CRD section, right? You can create, I mean, Kubernetes has resources like pods, nodes, daemon sets, config maps, secrets, all of these. And if you want to create your own resource, you can pretty, I mean, you can do that in a pretty straightforward way. Like, and then you have got the scheduler, and scheduler basically schedules your workload on the Kubernetes cluster, and it has a predetermined set of predicates and rules on which it ranks your nodes, and it decides where your workload should be running. You can create your own scheduler, and you can set up your own rules to decide what ranking should be given to your nodes, right? And then, of course, controller. When you are creating your new resources, you need a mechanism to control what happens to these resources, right? Kubernetes has built-in resources and built-in controllers for these resources. But if you create a new resources, you can write a new controller that can take care of what happens to these resources, right? You can extend network as well. We have got a concept of CNI, that's container network interface. There are a lot of CNI plugins available, like Calico, VNet, right? And as long as you adhere to the API rules, you can virtually do anything, right? That's like an outsourcing mechanism for the cluster, right? I mean, you just need to follow a set of API rules, and then you can just design your network plugin in a way you want, right? And same goes for storage, right? Like CNI, we have got CSI, that's container storage interface, and as long as you adhere to those set of APIs, you can virtually manage your storage in a way you want, right? So basically, from a Kubernetes point of view, uh, you can extend each and every single component of it, right? And that's one of the biggest capability that Kubernetes provides. Now, I want to talk a bit about custom resources, right? As I said, this is one of the most used ways to extend Kubernetes, right? And what it provides is a resource in Kubernetes is basically an endpoint that's going to store a collection of objects, right? Like when you talk about pod, or when you talk about deployment, when you talk about replica set, this resource basically contain a collection of these objects, right? So what you can do is you can create your own resource, right? And you can use it like you would be using any other Kubernetes resource, right? Let's say tomorrow I create a resource named Piyush, right? I can just create that in my cluster, and it can store, a collection of Piyush objects, right? If there are multiple Piyush available in the cluster, right? So, and one of the good thing about custom resources is they can be added, removed via dynamic registration, right? You don't need to, restart those services, right? And that basically helps when you are, and it becomes more important when you are running in a managed environment, right? If you are using a managed Kubernetes, probably, let's say either from Amazon or from Google or from DigitalOcean, in those kind of environments, you don't get access to the master component of Kubernetes, right? And if you want to enable something, you don't have the power to basically restart those services, right? So uh, custom resources doesn't require that, right? You can do that in a running cluster, right, as we will see in the demo in a minute, right? And you can talk to these resources via kubectl, just like you would be talking to, you know, any other resource, right? And you can couple them with custom controller that can take action on these resources, and you can basically get a true declarative API, just like any other Kubernetes resource, right? So you can create the resource, and you can also, I mean, just to give you a contrast with the built-in resources, when you create a pod object, there is a controller that is running that makes sure that pod is scheduled on a particular node, and then that pod is, you know, deployed on a particular node, and in the end of the day the container gets up, right? And all of this is run, all of this is made sure by a pod controller, right? So you can write your own controller and for your custom resources, and you know, this makes a whole declarative API possible, just like Kubernetes, right? And I mean, this particular concept is so popular, right? There have been talks about creating um, everything as an extension for Kubernetes, right? In the end of the day, only API server would remain, right? And you can basically create resources as you want, right? There would be no probably built-in resources, and you know, that might be the future for Kubernetes, right? And the second part I want to talk about is the aggregated APIs, right? And what aggregated API is, it is basically extending your API server, right? So there's a component called aggregation layer, and it runs with API server, right? And like every good thing in Kubernetes, if you want to extend API server, you can run your own API server in another pod, right? Now, this use case is mostly helpful when you want to, you know, create your authentication or your admission control and all those kind of things, right? So what you can do is you can run a custom API server inside a pod, right? And you can register it, you know, with the API service object, right? And whenever there's a call that's coming for that particular path, right? If I, let's say I created a new API server on the, you know, path, let's say /Piyush, right? If there is any request that is coming onto that path, the main API server is going to transfer that request to my custom API server, right? And there is usually a there's usually a restriction of 5 seconds delay in the round trip, but that's configurable. You can usually change, yeah, you can change that, but uh, don't make it too much, right? That's not advisable. Otherwise, you know, your cluster would be working at a slower pace, right? But in the end of the day, the idea is aggregation layer is a component that makes all of this possible, and it runs just as a proxy, right? So whenever there's a request coming to the main API server on a path that is registered with, you know, my custom API path, right? It's just going to proxy that request back to my custom API server, and I can take action on that accordingly, right? And what happens when you know, combine both of these? And I know this is a very toned down definition of operator, right? But what basically operators are, right? And the aim of operators is to uh, automate what an human operator does. Right now, think of it in a way where uh, you know, a Kubernetes cluster administrator, right? What or a Kubernetes cluster operator, right? What that person would be doing, that person would be basically watching the resources and taking action on whatever happened to that resources. If a new resource is created, then what they should be doing, and then if that resource is deleted, then what they should be doing, and if there is an error, right? I mean, auto healing is one of the biggest capability of Kubernetes, right? What they should be doing if there is an error, right? And what if you can automate all of this process, right? And that's where you get the operator pattern, right? You can basically add your custom resources, and you can add controllers that can watch over on that resource, and you know, they can take action accordingly, right? That's what operator is all about. So I just wanted to go through a quick demo on about CRDs. I hope my terminal is visible. Uh,
Piyush.
yeah, thanks. Right. So let me just see if I am connected to a cluster. So this is a DigitalOcean managed Kubernetes, right? And what I want to show you here is you can define these custom resources just like you would define any other resource, right? Just like you would define a probably a pod or probably a deployment or a replica set. Right? Now, if you look here, and I will just walk you through this YML, the API version that or the API group that this custom resource belong to, it's the API extension.kds.io, right? I'm using, I guess it's the Kubernetes version is 1.18.8, right? As I said, right, Kubernetes is a highly evolving project, right? So there are a lot of features that keep moving. So just make sure you are using the right API group if you are trying to do it on your own cluster, right? The kind is the custom resource definition, right? I'll just put the name in, right? And you can basically scope it out, right? You can make sure that that particular custom resource is available cluster wide, or it might be available on your just on your namespace, right? And this is a helpful tool for cluster administrators as well. I mean, you might not want to everyone to get access to this particular resource, so you can just scope it out to the namespace, right? And this basically outlines what it would be called, right? So I'm creating a custom resource called image store, and the kind would be image store. Singularly, it would be called image store, and plural, in a plural form, it would be called image stores, right? And I'm also giving it a short name that's called IS, right? Uh, this is basically similar to when you do a kubectl get deployment and kubectl get deploy, right? So that's just the short name for it, right? It belongs to the group example.com. We will see how it matters, right? And you can also manage multiple versions here, right? If you want to update your custom resource, you can basically have multiple versions here, and the version that has served set as true, that would be the active one, right? And then and this section basically helps you define what exactly that custom resource would be containing, right? So in my resource, I'm going to have two things. One is going to be image, right? And one is going to be registry, and both of them are going to be type of string, right? So what I want to do is I want to create an image store where I will be storing a image name and which registry it belongs to, right? So let's create this image store, right? Now we can just look at the CRDs, and we can just make sure that our CRD was created, right? And there are a lot of all CRDs already running in your Kubernetes cluster, right? So there are a lot of components that actually run as CRDs, right? We just added one more to it. Now let's create an object of this resource, right? For that, I have the object, and so this is where the group comes into the picture that we saw in the last YML. This is the version. The kind would be image store, just like you would put kind as pod, and then you can put a name to it, and it will contain these two values, right? The image name is test image, and the registry it belongs to is called docker.io. Right? So I can just now I can create it just like any other resource in in the Kubernetes environment, right? So now once I do that, Kubernetes knows that okay, this is going to be a custom resource, because this is not a pre-built resource or a primitive resource, right? It's not a pod, it's not a deployment, it's just a kind of image store, right? And but since I have that extending capability, I can just talk to it. Just I would be talking to any other Kubernetes resource, right? Let's say kubectl get is, right? And is, if you remember, we put the is as a short name. You can also call it image store, right? You will basically get the same result, right? And you remember the name you put as was my image, and you can do all sort of things like you would do with any any primitive Kubernetes resource, right? So you can just describe it, and it will show you all the things, all the relevant versions, right? And whatever data it contains, right? This basically makes Kubernetes a lot powerful in a way where you can just add your own resources and you can just talk to them in a way where you would talk to primitive Kubernetes APIs, right? Coming back to my presentation. Right. And how, I mean, we saw a demo of how you can create a resource, right? Creating an operator or creating a controller is a bit complicated task than that, right? Creating a resource is, pretty straightforward stuff. And to make that task easy, there are a lot of tools available in the market. One of the tool is called Operator SDK, right? And what it basically does is it provides you high-level APIs and abstraction to write the logic more intuitively. It has tools for scaffolding and code generation, right? So it can create a lot of code in advance for you based on the information you provide to the tool, and it also has extensions to cover common operator use cases, right? So if you want to create a Kubernetes operator and or your own controller with resources, you can take a look at Operator SDK. It has support for Go, Ansible, and Helm, and it's not the only option. I mean, based on your comfort level, you can use Kudo, Kube Builder, or Meta Controller as well. And there are other extensions. We talked about them in the earlier slides, right? You can use network plugins like CNI and KubeNet. They help you extend networking component of Kubernetes. You have storage plugins like Flex Volume Driver and CSI drivers, right? They can help you extend storage part of Kubernetes. And you also have device plugins. I mean, if you are using specific sort of hard disk on one of your nodes, or if you are using, let's say, GPU based systems, right, you can use device plugins to connect your Kubernetes or use your Kubernetes cluster in an efficient way, right? And this is one of the last things that I want to talk about, and that's service catalog, right? And the way it helps you is, uh, let's say you're running a Kubernetes cluster, right? And you want to use a managed service from a managed provider, right? Be it anyone, right? Be it Amazon, be it Google, be it DigitalOcean, right? And but you don't want to take the burden of setting everything up and installing it and making sure that things are working fine, right? What you can do is you can use Service Catalog, or you can use the Open Service Broker API to talk to the that managed service, and you can use an instance of that managed service in your cluster, right, without needing or without having to worry about the underlying implementation detail of that service, right? So if you look at the diagram, you have got the Service Broker API, and this is what talks to the managed service and your cluster, right? That's like a bridge between your cluster and the managed service, right? And uh, once you set that bridge up, your application can use that managed service just like it would use any other application that is available in the cluster, right? I'm not sure if this is being developed actively, right? But it's one of the ways where you can use or where you can extend Kubernetes capabilities via a managed service provider. So that's all I had. Thank you for being a brilliant audience. You can get in touch. There are some contact details on the slides, right? You can take a look. And for the bonus part now, if you want to try out DigitalOcean, and if you want to try out our managed Kubernetes, if you want to play around with how Kubernetes works, right, how you can extend it, right, you can go to the link. That's do.co/Piyush. P is capital there, right? Just remember that. Otherwise, you're going to get a 404. And you can get $100 credits, and you can use those credits to set up a Kubernetes cluster, play around with it, create your own resources, create your own controllers, right, and all those things, right? So I guess I'm doing good on time. If there are any questions, I would be happy to answer.
Thanks, Piyush.
Hello.
Hello.
Yeah.
So there is one question there. So they're asking what is the difference between K3s and K8s? Are they the same thing or they are different things?
Okay. Right. So K3s is the way to install Kubernetes. It's it is it is Okay, so let's just take a step back, right? When you install or when you deploy a Kubernetes cluster, right, there are a lot of components involved there, right? Kubernetes is a complicated distributed system, right? You have got master components, you have got node components, and all those things, right? And installing it is a task, right? That's why you have so many projects that are dedicated to just install Kubernetes, right? I mean, KubeADM, Minikube, KOps, and all those kind of things, right? What K3s provides is it tones down some of the components that might not be required for an standard installation, right? So, uh, just putting it in a plain simple way, K3s would be a toned down version of a big Kubernetes cluster, right? So that's the difference between both of these.
So one another question is that, so how can we have a zero downtime on Kubernetes cluster? What are the good practices that one should ensure so that application has zero downtime?
Right. And again, Kubernetes does provide you that capability where you can do something known as a rolling update, right? Where you don't need to change all your application copies, right? Think of it this way. When you are running a Kubernetes cluster and when you are running your application, let's say you are running 10 replicas of your application, right? Now you want to, you have a new version coming up, right? So you can set up your requirements as that you won't be changing all the replicas at once, right? Probably you start changing two of them and three of them, and you can set up limits on those, right? How many of them you want to be updated at one single point of time, right? And how many of them should be available at a certain point of time, right? Based on that configuration, let's say you set up that at any point of time, three copies or three replicas of that application should be available, right? So now when you put up that update, Kubernetes makes sure that at any point of time, at least three copies of your application or of your application are actually serving the customer, right? And it would do that in batches, right? Let's say first three and then three and then three and that one, right? And that's how all of your 10 copies get updated, and your customer also don't face any downtime. So always, whenever on the best practice front, always make sure whenever you are doing update, you set up the max search limitations and max availability limitations, so that you have a certain set of replicas always up and running and serving your customers.
Okay. So no, I don't think there are many more questions. So thanks, Piyush. Thanks, Piyush, for your valuable time and your valuable speech on extending Kubernetes and why we need to extend it. What are the difficulties we were facing? Okay, thanks,
Good to be
Piyush.
here. Yeah, thank you.
So let's move forward. And next speaker we have is Apurva Bhandari. So he is a site reliability engineer at Viewclip, Pune. He has 5+ experience in DevOps and SRE field with the product-based companies. He is more focused towards container and orchestration family using Docker and Kubernetes. He is also more passionate about cloud native technologies, and he thinks knowledge is a great way to share. And he also tries to help people with so that they can grow with their confidence. So he has been a speaker at various meetups and technology events. So he's guiding many youngsters and people, and he's one of the organizers of OSCONF and various technology meetups groups. You can always reach out to him at Twitter and LinkedIn. We'll be sharing his profile on the chat box. So Apurv, can you go ahead and
Hello everyone, you are able to see my screen?
yeah, we are able to.
Okay. Just a second. Thanks Hemant for the introduction. So I will not waste my time to introduce myself. So let's move ahead to the actual topic. What I want to deliver today is like Kubernetes networking and how we can view from from the basic to advanced networking from the Kubernetes native networking, and if I am using the service mesh like Istio, and that point of view, how I can see the networking, those couple of things like we can say. So today I will not going to show any demo or something fancy like that, but I will more concentrate on the how we can go in a conceptual way. So, yeah. So this is about myself. Already Himank already introduced. So let's start. So this will be today's agenda. Like first of all, we'll go through the basics of the Kubernetes networking of the Kubernetes. Then advanced routing, we'll check it out, like how we are doing the routing from the service to service, or if I'm hitting any service from outside the world, like how we can connect to the service, that we can check it out. Next, like we can check it out like some basic stuffs about the service mesh and Istio, and the traffic routing by the Istio. The next thing is like we will go with the networking with the Istio and the routing part. Okay, so first of all, we'll see like what are the services are there in the Kubernetes. So if we check like there are like four basic services like cluster IP, node port, then load balancer, and then the external name. So basically, if you look at the diagram which I have shown, like if I want to connect to any service, or if I want to expose any service inside the Kubernetes, so there are like if I want to expose the service inside the Kubernetes, so I will go with the cluster IP. So I don't want to expose that service outside the cluster. If I want to access the service outside the cluster and I have the access to the node, then I will expose it onto the node port. If I want, if I'm spinning up anything, on my cloud, so I can go with the load balancer service, where I can expose my service onto the load balancer, and I can access my application outside the world. So these are like some of the basic services which I can say into the Kubernetes. So next part, like if I'm talking about like cluster IP, how the pod, if I am exposing any service to the pod. So if I write down the any deployment, and if I want to communicate, or if I want to access the application, so what I will do, I will write down the manifest file for the, let's consider here I am deploying any application with the label like Nginx. So I'll deploy that application. I will write down one service. In the service, I will write it down. The type is equal to cluster IP. So the manifest which I wrote in the right side, you are able to see like I have written like type is cluster IP. So this application will get exposed onto the 80. The port is 80 and target port, which the container port we have mentioned over here. And based on your labels and selectors, what we have mentioned in the deployment and the service, according to that it will get connected. So behind the scene, if I want to talk about like how it will get connected, so service is a different entity and the deployment is a different entity. So behind the scene, if I talk about the services, so services is maintaining the endpoints, and at the endpoint level, it will try to watch the pods which is matching to the selectors. So here I have mentioned like selector is equal to, selectors are like env is equal to prod, and the same labels, the service will say check it out like what are the deployments having the same labels. And at the endpoint, it will try to maintain all the IP tables, like what are the pods IPs are there, which is having the env is equal to prod. Those IPs will get connected. Those IP will get added into your endpoints. So automatically, when I'm just trying to hit any service with the label env is equal to prod, env is equal to prod, so it will get connected to my Nginx pod. So next thing, like if I want to talk about the node port. So node port basically it's like again it's a limited range of ports. It comes from like 30,000 to 32767. basically it opens the port onto your node. So what are the nodes you are running into your Kubernetes clusters? Those on that node, the port will get exposed. So here, if I check about the manifest file, I have wrote like type is equal to node port. So over here, I'm just exposing my Nginx pod with the port 30,001. So again, my container port is 80. So 80 port is mapping to my 30,001. So if I want to access my Nginx pod on my local desktop, or if I have the access to my nodes, so I can just put it down my node IP colon the 3001. So I am able to access the Nginx pod. The next service is like load balancer. Same if I want to talk about like the behind the scene. So again, load balancer is a service which extensively provided by your cloud provider. If I expose any service onto the load balancer and I mention the manifest file that type is equal to load balancer, so it will get mapped with the public IP with one of the port that what I have mentioned over here, like 8080. Here I have exposed like a pod onto like app is equal to Nginx or env is equal to prod, and behind the scene it is mapping to your 8080 port. Again, if I want to talk about the work flow from your external IP to the pod, so first of all, my public IP will get mapped with the target port that what I have mentioned over here, like 8080. So I will put it down like public IP colon 8080. Behind the scene, again, load balancer is mapping to your node port. So that node port I have mentioned over here, like 31768. From node port to it will again point to your cluster IP. So this is like workflow. If you look out from the top of the service, and I'm hitting to any service which is running inside my Kubernetes cluster. So first it will hit to your load balancer public IP, then it will go to your node port. From node port to it will map to your cluster IP. So if I talk about like cluster IP is like virtual IP which is running inside the Kubernetes cluster, which I have exposed. Like this virtual IP is connected with like your services, and this cluster IP will get connect to your multiple pods. Okay, so this like external name. So this like is kind of like I'm mapping the service like or the DNS mapping to any service that I want to map inside, which is running inside my Kubernetes. So for that we are using external name. So yeah, so if I talk deep dive into like the things like which are running inside the Kubernetes, they're like I am exposing any service. Let's say consider on cluster IP node port or load balancer, what it does it like if I'm talking about like there are like 3 modes where I'm hitting any service. So what it will do if I talk about like the worker nodes, we are running the kube proxy on each and every nodes, and kube proxy, what kube proxy will do, kube proxy will route that traffic to your pod. So if I am hitting, like if you check about these diagrams, so the client which I am just sitting the guy who is hitting the service. So from client to if I want to reach to my pod, so these are like multiple ways, or these are the multiple service, or I can say like these are the multiple ways you can reach out to your pod. So there are like 3 ways like how we kube proxy modes are. Like first is user space mode, second one is like IP table proxy mode, and third one is a IPVS proxy mode. So if I want to talk about like there are like slight difference in between like these 3 mode, not into in a bigger mode for the bigger way. If I want to like talk about like user space proxy mode, then like it will kube proxy watches the Kubernetes master for the additional and removal of the services and the endpoint object, and for it opens like randomly choosing the local on the local node. And what it does, it like it will connect with the proxy port. On the proxy port, it will get connected to your pod, actual pod. And user space mode actually install the IP table rules which capture the traffic from the cluster IP and the port. So behind the scene, again, it will install the IP tables and it will route the traffic to your kubeproxy, and kubeproxy will take care of that routing the traffic to the actual pod. So if I want to talk about like IP tables mode, IP table proxy mode. So this is like common mode, I could say, like it will again, so it install the IP table rules which capture the traffic from the cluster IP and the port and redirect the traffic to one of the service in the backend set. It install like IP table rules which select the backend pod. So what are the things behind the scene it is running? So kubeproxy will pass that traffic to your cluster IP. So if I want to talk about like IPVS mode, so this is slightly different things. Like kubeproxy watches the service and endpoints and call the netlink interface to create one IPVS, like a virtual IP, or I could say like a virtual server. And accordingly, it will synchronize the IPVS rule with your Kubernetes services and the endpoints. And this is like way like it will get connected. Like here, if I want to send the traffic, there are like multiple modes. IPVS does is like it uses the round robin, or it may be using service hash mapping, source hashing, or it may be like the destination hashing. That depend on like what type of mode it is using. Depend on that, IPVS will route your traffic to actual pod. So this is what I am just trying to explain. If you look at the from the top view, like if I am hitting to any service from the kube API, so first it will get connected to your service, and service at the service backend it is maintaining the IP tables with the help of endpoints. So let's consider I have one Python application and I want to access that application with the help of Nginx. So first I will hit to the Nginx server. So it will go to your kubeproxy, and kubeproxy has this any of this mode, like where to route the traffic, and from the service it will get connected to your Python application. So if you look at the right hand side, if I'm not wrong, you are able to see these things. So if I am exposing the service with the help of like load balancer or the external traffic, so this is like how we will get connected to your actual pod. So again, behind the scene, load balancer will get connected to your node port. From node port, it will get connected to your cluster IP where all the IP tables are there, and from there, the kubeproxy will route your traffic to actual pod. So here we have like 2 nodes, and the 3 pods are running behind the scene. And how this traffic will flow, you can check it out like in the right side. Like cloud provider control will take care of the like provisioning of the load balancer service, and it will take care of like taking the call from the external. It will take the traffic from the external world, and it will say redirect the traffic to your actual pod. Is there any questions till now? Okay. Okay. So in the last section, like we have seen like how external traffic will come to your pod. So this is what I am I want to try to explain you. If you check out the middle diagram, if I'm exposing any service, so don't worry. Like if I'm creating any service like a load balancer, or if I'm creating the node port type of service, behind the scene it is actually going to create the cluster IP. Or if I am creating any service like load balancer, it is creating the node port and cluster IP too. So if you look at the right side, left hand side of the diagram, so here you will come to know like how traffic exactly reaching to your pod. So if you look at the top level, like external traffic, and if you look at like 4.4.4.1, so this 4.4.4.1 is like external IP of your node, and it is mapping to 30,080 port. And again, these 2 ports are get connected to your load balancer service, and from load balancer I am able to access the service. So if you ask me like why there are like two IPs, so again these are like if I talk about like 4441, it is the external IP of your node. If I talk about like 1111, it is the internal IP of your node. So I am exposing any service, that means it is get mapped with your 30,080 with your internal and external IP of your node, and it will get connected to your load balancer. And how this is like how you can think like how traffic are flowing from external to the your pod. If you look at like downside like service Python load balancer service, and if you ask like if you think like what is like 1.1.10.1, so this is what like I am just trying to say, like 11.10.1 is like cluster IP, and it will get mapped with your 30,004. And again at the lowest level, this cluster IP will redirect your application traffic, Kubernetes traffic to your actual pod. So behind the scene, if you look at the Python pod like 111635, those are like Python pod, and it will get connected to your cluster IP against 3000, and 11.10.1 cluster IP will get connected to your node pod with like 111 30,080 or 4441, and from 4441 it will get connected to your external load balancer. So I hope like it is like pretty clear like how traffic flows from if I'm hitting any service from the external world to the actual pod. So if you look at the extremely right hand side of the diagram, so if you check like external traffic and how it flows. So let's just think I have like multiple services and like multiple applications which are running behind the Kubernetes cluster, and those are like multiple microservices are there, and I think like more than like let's consider 20 or 30 microservices are running inside my cluster. Then how I can manage those things? Because if you check about like load balancer service too, so again behind the scene it is creating the node ports, and node port, if you talk about the node ports, it is having the limited range of like 30,000 to 3767. So in between, if I exhausting this port range, and then what will be the next things, like if I have exhausted with the ports, then the new service I want to access outside the Kubernetes cluster, that I cannot do. So for that, we can use like the new things comes in a picture called as ingress controller, where what I will do, I will only expose the ingress controller with the help of ingress rule with the load balancer, and rest of the traffic I will manage with the help of like ingress rule behind the scene. So if I look at the like extreme right hand side diagram, so you can see like I have deployed one ingress controller, and with the help of like ingress controller, I am just routing the traffic to actual pod. And this is the way like how I can save the ports. And again, if I talk about the security level, so I can secure my application. So this is like how we can see like from like how traffic flows. If I talk about like how and till the time like if you think like how traffic flows and how it happens, so if you think like it is like all the things are flowing with the your IP only. So if I'm hitting to any IP, from it will route to traffic from IP to IP tables and all those stuff. So again, it is a L3 type of traffic routing, where all the traffic will get mapped to your IP and IP tables and IP route, and it will route the traffic to your actual pod. If I let's suppose I have like application which is having like load balancer kind of stuff. So I have like HTTP or HTTP based application. I want to secure that application. How we can do with these things? So definitely it is like L3 kind of application. L3 type of routing. Here I cannot do those things. So if you consider like if I want to talk about like in a AWS way, so I have like NLB and ALB. So if I want to route the traffic a more faster way with the static IP, I will go with the NLB. And if I want to secure the traffic, I want to do the caching, or I want to do the secure the traffic with the multiple ways, I will go with the ALB, application load balancer. And this is the what I'm just trying to explain, like why I'm using the application or L7 type of traffic routing or networking rather than the L3. So this is like why service mesh comes in a picture. Like if I want to talk about like service mesh, so today I will just going to cover the Istio and why Istio. So that I'm just going to explain you after this slide. So what service mesh is like? Service mesh is like open service platform that to manage the service and interaction with the containers. So we'll just check it out. Like if I want to do the service to service communication, so I can do with the service mesh. But what exactly Istio does is Istio does more than the what service only service mesh do is. Behind the scene, if I talk about the Istio is using NY proxy to route the traffic. So we'll see one by one. So these are like some of the things that Istio does is like intelligence routing. Intelligent routing. From that we can do like controlling in between like dynamic configuration, or if I want to do the canary deployments or A/B testing, like or blue-green type of deployment, that I can do with the Istio. If I talk about like resilience, like it's a more like mature way how we can do and play around the application. It is like if I want to check the health or timeout or circuit breaks, like I'm using Hystrix or something something like that I can do with the resiliency. If I want to secure traffic, this is the more proper way why I'm service mesh is using with the and how I can secure my traffic at the application layer. Just this is the way like I want to just explain you like why I'm using L7 rather than the L3. Here I can use like a mutual TLS. I can inject with in between two services which are running inside the cluster, and I can control the traffic, and I can do the like encryption of the traffic, and I can play around that. And last not the least one, the telemetry one. Why telemetry? If you know about the Kiali dashboard or something, telemetry or tracing of the calls, that can easily do with the help of like telemetry. That again, this feature is provided by the Istio. What Istio value proportion is like it's like securing the call like authentication, and again it is not relying on to your L3 controls. It has like a uniform service to service layer observability that I can do with like what are the signals and traffic flows. I can collect the logs what from which service to which service it is like call is going, that calls and that signals I can capture. If I am talking about like traffic management and operation agility, like I can see like how service behaves, and I can control the traffics, and I can again do the like policy and traffic routing rules where I can set particular traffic to one pod and or particular deployment, and if I want to upgrade the deployment with another version, I can send the traffic like in a percentage wise. Like if I want to send the 50% of traffic to the old one, 50% of traffic to the new version of the application, that I can easily do with the help of Istio. So these are like some of the aspects that I want to show you, like uniform observability that we can trace it out, like operational agility where I can do like these are the some of the way, like if I'm doing the canary deployments, I can control the traffic. Like if I have the different application, I have like two application where one application is running for Android, one is application running for Apple, so that I can do with the help of like Istio. Again, the security perspective, like I can enable the mutual TLS authentication and encryption. I can control over the identity, and I can configure those things at the configuration that I can do in the virtual service, and the destination rule that I can write into the Istio. Again, if I am talking about like it supports like REST and gRPC, at gRPC and REST API level call, I can just have the control, like I can do the core policies, and I can block the headers, and if I want to allow some headers, that I can do with the virtual service of the Istio. So if I want to talk about like like networking proxy types. So these are like some of the networking proxy type, like middle proxy, edge proxy, embedded client library proxy, or the client side or sidecar proxy. So these are some of the networking proxies that how we can route the traffic. So here, if I talk about the Istio is using like sidecar proxy or the client side proxy. What we can say is, so a bit about if I don't want to waste much more time explaining like what middle proxy or what edge proxy or client proxy. If you look at the first diagram, it is like middle proxy. Second one is like client edge proxies. Third one is like client library. So if I want to bit talk about like middle proxy, so again is most familiar, like I'm using like Juniper F5 or like I'm using a LB or NLB kind of stuff. So that one is a middle proxy. If I want to like edge proxy, so I want to use like a API gateway kind of stuffs, and like it is using like a proxy topology. And 1 second. Okay. Okay. I'll take the questions later on. Okay. So if I want to talk about like edge proxy, so I can do like a TLS termination and all those stuff. I can use like edge proxy. If I want to talk about like embedded client library traffic routing at this level. So if you are a developer, then you definitely know like Rebound or Hystrix type of service or gRPC type of client library that I can embed it with my code, and this is where like how I can route the traffic. But again, this is like a dependency. I want to integrate this library with my code, and again I have to deploy the code. So if I want to talk about the client library type of proxy, it is much more faster, but again your application will get bulky. So if I want to talk about like sidecar proxy, what sidecar does, again it is not like 100% sure, or it is a definitely faster way to route the traffic, but definitely there are like a lot of pros, rather than if I look at the other proxies. I have like client side load balancing. I can do like it is not like a traditional like L4 level of traffic routing. It is if I talk about like sidecar proxies, it's a more lightweight. Then I can do the I can scale the sidecar proxy. It is not sitting in your code, just like a client library, and they can do the load balancing. So next we'll see like more about the sidecar proxies. Do we have like Istio Slack where I can join and there is a Istio Slacks too. Like there are multiple companies who are contributing to the Istio, and after that I'll paste the link into the chat itself. How could we do horizontal pod scaling based on the custom Istio matrices? That I will explain you, but I don't think like we need to do like HPA kind of stuff with the help of like Istio, but yes, we can do those things. Because mostly if I talk about the HPA mostly works on like three things. Like if I want to, there are like three modes. Like I can do with the custom matrices and the standard matrices like CPU and RAM based scaling, and those will be sufficient to scale the application. If I want to do the custom matrices based application, then again definitely you have to be 100% sure that I can scale the application on these matrices, and then only you can use this matrices to scale the application. If you are not sure about how custom matrices are going to behave, definitely I will not recommend it to go with the custom matrices, because again that will be again a bottleneck for you. Okay, so if I want to talk about like sidecar, what sidecar does is like it will get deployed to your application, so you don't worry about the how application is. If I want to enable the sidecar or the NY proxy deployed to with your application, you can just have to enable the Istio with your namespace. So one more, when you are trying to deploy any application into the Kubernetes, so it will not only the application. So with your application pod, there one more container will get spin up in your pod. That is I could say like Istio proxies or the NY proxy, which will get spin up with your application. And these NY proxies will have actual routing of your traffic. So this is like some of the beauty of like what sidecar does is like it redirect the traffic, enforcing the policies, report the telemetries and all. There are like no, as I earlier explained, there are no client library embedded with your code because it runs with along with your code. It is not integrated directly with your code. So if I want to talk about something like NY proxy, so these are the things like it is lightweight, low memory footprints. It is already graduated projects, CNCF graduated projects. Then they're like you talk about the contribution, then it is using the lot of beautiful things about the Istio. It will do the fault injection. Then you can use Zipkin for tracing those things. You can route the traffic and split the traffic. That will I will going to explain the about after the few slides. Not much wasting of the time. If I want to look at the Istio architecture, here you go. If I am talking about like Istio version from 1.5 and above, like currently it is 1.7. So these are the control plane components get merged into Istio D. And all again, if I talk about like before the 1.5, they're like pilot, mixer and citadel and all those stuffs. Those are like again the same component of Istio D only. So in the next like 1.5 and above version, all the components are get embedded into one single component, that is Istio D. So bit about like architecture point of view. If I look at the architecture diagram, you are definitely come to know why I am running any service and my proxies are running with my service. And if I want to route the traffic, I can do with the traffic with the help of like proxy, Istio proxy. Or again, if I want to say like sometimes I could say like it's Istio proxy, but Istio proxy again running the NY proxy only. It's not develop anything something else. So if I want to talk about like pilot pushes the service registry info and routing rules to the NY proxy. So what are the rules and NY proxies? The registry infos are there that I can do with like that proxy pilot will do. What mixer is do? Mixer has like open API and pluggable architecture, like sending the telemetry logs and traces of your what you have choice, like that can be done with the help of like mixer. Again that is your choice what exactly you need to take out from the like telemetry and the logs and all those stuffs. If I want to talk about the citadel more, it's like this is the way actually what exactly will happen. Like if I want to encrypt the traffic, like with the MTLS or without MTLS, or what I have like HTTP, HTTPS, or gRPC or TCP, whatever things are there, that will take care by the citadel. And citadel will make sure that like application identity is propagated as a like bearer token and all those stuffs, and all the encryption of the application of the traffic, that will take care by the citadel itself. Citadel mixer, the telemetry config. Okay. Okay. So yeah. So once this is done, the pilot is already push all the routes to your proxies, so it is very easy for the proxy to get communicated in between service, or from if I have the external traffic that can land to your application, that will be very easy because you have the proxies which are running along with your application. Okay, so we'll go next. This is what I'm just trying to say, like in 1.5 and above version, all the components will get seated into your single as a control plane, like with the help of like istio-d, and rest of the things, like if I'm talking about like if I will say like control plane is like server side, and if I talk about like proxies and so sidecars, that will be, I could say, like client side proxies. So little bit like about these things, like if I want to do like if I want to like talk about like pilot, so it will help like traffic management, then intelligence routing, which allows you to do like A/B type of testing or blue-green type of or canary rollout on all those things. If you have like a circuit break and all those stuffs, which I have already explained, that will take care by your pilot. And pilot like it's like a management traffic pilot is pilot is much aware about like what platform is running on, and it will ensure that the traffic management part, and it will not it is again irrespective of your platform, what platform you are using. If I want to talk about like more about the Citadel things, so I already explained like the certificate management and traffic encryption and all those stuffs that will be taken care by the Citadel. If I want to talk about like Gelai, so Gelai is responsible to provide the configuration, validation, like ingestion, then what are the processing and distribution for your service mesh, that will take care by the Gelai. If I want to like talk about like traffic control, then the traffic control there, that will help to control your traffic and how it moves through your traffic, such as like providing the routing rules and HTTP, those that will take care by the like traffic control, or the that will take care by like traffic control things. So if I want to talk about some like network resiliency, so this will help you like providing the network resiliency, such as like retries or failure, circuit breaks, and fault injection. If I want to talk about like security and authentication, so that will again take care by like mutual TLS and traffic encryption. And if I have like if I'm using like MTLS, then it can again preventing the man-in-middle attack and all those stuffs. This is what like if I'm looking out like top of the diagram, I'm hitting any service from the outside the Kubernetes, and if I want to access any service inside the Kubernetes, and if I have deployed anything inside the cluster, so if I'm hitting like into the public internet, so Istio has like Istio gateway with us, and from Istio gateway to it will connect to again Istio gateway is running the server side proxies, and from server side proxies the traffic will get to your mesh proxy, that is NY proxy, and how this is flow. So if I am done with my traffic routing from service A to B, and if I want to again send the data outside the world, again behind the scene it is running the external egress gateway, and egress gateway will send the traffic outside the world. I think this diagram is pretty much clear, and you are able to see how traffic flows from like from external world to the internal proxy, and from the internal proxies to the outside the world again. and those traffic will flow from your proxies to proxy. And let's consider my have like Istio deployed in my cluster and my control planes goes down, or my Istio goes down, then what about my services, or what about my NY proxies? So don't worry about that, because at the starting time itself, the pilot or STOD is pushing those rules into your NY proxies. So in case like your STOD or control planes goes down, still your application will is running fine, unless and until your NY proxies are live and they are connected to each other. The only thing is that if I am scaling the application, or if I am adding new stuff into the cluster, then that time only NY proxies don't have those rules. So the new pod will not get served with the new traffics. The only thing is that if Istio is live, STOD is live, then you don't need to worry about those things. So these are the like more granular way, I could say, like if I want to send the traffic from, these are the, if you ask me, like these are some of the things which runs with the Istio, like virtual service, then virtual gateways, then destination rules, and the Istio gateway, sorry, ingress gateway. So these are the things which running inside, like with the help of like Istio. So here I have write like if I'm hitting to service A, it will go in the destination rule. I have wrote like the my traffic will go to service A and sorry, service B with like version production. And one of the things like I have wrote like version 2 have the canary, so that I can write into the destination rule and I can route the traffics. Oh yeah, so earlier we see like how traffic flows from like L3 level or with the help of kubectl. Those similar way I can see like from this diagram you are able to see, and this is like more granular way. If I'm hitting to any service from outside the cluster, or with the help of load balancer, or with the help of like Istio gateway, so I'm hitting to the load balancer, the traffic will flow from load balancer to the Istio gateway. Like it again, as I told you, Istio proxy, these are the NY proxies which is running with Istio D. Like these are like server side proxies. And if I'm talking about the proxies, which is if you look at the pod 1 Nginx, like Istio proxy, Nginx Istio proxy, those are like client side proxies which are running with your application. So if I'm hitting the application with load balancer, so it will first hit to your Istio gateway. From Istio proxy NY, it will get connected to your Istio proxy, and behind the Nginx, my Python pod is running, and it will get connected to your Python application. So if you look at the traffic flow from external to the actual pod, so those are like from NY to NY or proxy to proxy, and that will be totally encrypted traffic, and it is again the layer 7 traffic. And in between like that, you can do the lot of things like resiliency or traffic routing or encryption security level or traffic management. There are a lot of things that you can do. So if you look at the right hand side of the diagram, they're like you can much more clear about the things like how we can access the things inside the cluster. Like I have the routing rules and policy which already push to your proxies, and proxies have those information, and I'm hitting the traffic. So directly, if you look at like traffic in the in a red color, so that traffic will inject to your Istio ingress gateway, and from there it will reach to your pod. So if I talk about like little bit about Istio gateway, Istio ingress gateway, so it has like virtual services, then gateway, then destination rules and all those stuff. And there these rules are written, and according to that the traffic will behave, or traffic will get routed. Like if I talk about like Istio is like a big things or service. If I talk about like service mesh 2, it's a big thing, and I cannot explain each and everything like in 30 minutes or 45 minutes. But I'll just try to cover all those things, and wanted to get clear all the concept behind the scene, what Istio does and what service mesh and how service mesh is running. These are the another beauty of Istio. I could say I have like 2 different cluster in a 2 different region, and I want to do the load balancing. Then I can deploy the Istio in between 2 clusters, and I can do the traffic routing. For this, I could say like multiple cluster with the service mesh. These are the information and how you can configure this. You can get easily come to know with the help of like on Istio. On the Istio website, how you can configure. There are a lot of things, not only this, like you can do like remote Istio traffic routing too, where I am running the Istio in one cluster. Only I am running the Istio in one cluster and have multiple clusters which are running, and I can route the traffic to the multiple clusters. Those also we can do with the help of Istio. So it's not like only the service mesh or the L3 layer of traffic. It's much more than that. So at the last, like some of the things that I want to just explain, like how traffic management kind of stuff like we can do. Like if I talk about like application rollout, I can separate the, like I can distribute the traffic in a percentage. Like I can decouple the traffic from the infrastructure, and I can scale the traffic. That is like a proportion of the traffic routed to a version, independent of the number of instances that are supporting to the versions. So if I want to like talk about like traffic steering, so again, as I shown in earlier diagram too, if I want to control the traffic based on my content base. So if I have the 2 devices which are running like Apple and Android application which are running in your cluster, that I can do with the help of like Istio, that I can do like with the help of like content based application, that I can do, and I can write the rules, and according to that traffic will get routed to your particular content based application. So if I want to talk about much more about the resiliency, there are like a lot of things for the resiliency I can do. Like if I have like the traffic that I want to send, and suppose my circuit breakers are there, and instead of that I want to do something else, and my application goes down, and there are like circuit breaks, that can I handle with the help of like resiliency. If I have the multiple applications and timeout between them, that I can reduce, that I can check it out like using the tracings. Then health checks of the application that I can see. Currently I haven't shown the Kiali dashboard, but definitely you can just check it out. Like what are the things in the tracing I can do. If I'm hitting to any service, I can trace the call from external world to the pod. That I can clearly show on my Kiali dashboard that how traffic flows from inside my cluster. And those tracing will be done by with the help of like Kiali dashboard with your NY proxy. NY proxy will send that telemetry data your Kiali dashboard. Like other things like fault injection and all those things, like those comes under the resiliency. And the connection control connection pool size and the request load, those are the some of the things that we can control with the help of Istio. I cannot go in deep into that, like we need to have one more session. If I talk about the efficiency, definitely it's load 7 L7 or the layer 7 layer of the traffic management, that we can do easily load balancing. We can do like TLS offloading, onloading. Then we can do like gRPC or HTTP or HTTP 2x2 proxying. Definitely. And behind the scene, if you ask me like, can I replace the total existing L3 IP based routing inside the cluster, which is a Kubernetes native with the help of like service mesh or Istio? Definitely not, because behind the scene again it is using the same things. But if you ask me like, if I want to replace the ingress controller of the Kubernetes, yes, definitely you can replace the ingress controller of your Kubernetes with Istio. Definitely like NY support like passive and active health checks, and usually you will get the benefit of that. And again, it is NY using like TLS. NY uses the boring SSL that will help like your Android and the Chrome browser too. So these are the some of the things like we can do with the traffic routing. So I'm much more ahead of the time. I know, but I have tried my best to explain all those things. Definitely, this is like I cannot say these are the full information or things that I want to cover. There are a lot of things that we can do. They're like 2 or 3 hours of session that only can cover only small part of the Istio. Yeah, definitely. Do you have any other questions for me? I know I am a bit fast while explaining, but I want to cover a lot many things over here. Okay. How can we deploy Istio on the Kubernetes cluster? Okay. How can we deploy Istio onto the Kubernetes cluster? There are like multiple ways you can do with the Istio CTL. Or you can directly the beauty of like GCP, if you ask me about the GCP, you can directly enable the Istio directly from the front end, or if you want to deploy manually, you can deploy manually. You can do with the Helm charts, or you can directly go to the istio.io where you will get the number of resources, like how you can deploy the Istio in your cluster. 1 second. How can I have the control planes outside the Kubernetes cluster? Yeah. How can I have the control plane outside the Kubernetes cluster? You can deploy the control plane outside the cluster. You can install the Kubernetes Istio D in one cluster, and you can easily connect the other clusters too. The only thing is that they should be having in a same network, or if they are not in the same network, you have to do the VPC peering kind of stuff where I can connect to other clusters too, and I can send the traffic to other clusters. This configuration, definitely you can check it out on the Istio page. You will get these things. And currently, if you talk about my current company, we are using the same scenario where I have the remote Istio which is running in one cluster, and I have multiple cluster which is running behind the scene, and I'm just routing those traffic inside my clusters. Outside the worlds means let's consider I am exposing any API with the help of Istio. Definitely it's a API based call if I want to go into deep. So if I have like test.com which is mapped to your Istio ingress, and if I want to access like test.com/prod, and if I want to consume the data, and definitely if I'm exposing any API, definitely I'm hitting to API, I will send the data to the API, and again I will get something from that API. So these are like outside the world means egress and ingress traffic to that API. What is Canary? Canary is like a deployment type where I'm just rolling out my application in a percentage, like let's consider I have like 10 pods are running, and if I want to deploy the new version of the application, so it will get roll out in a phase with the help of like Canary deployment. So in the first phase, if I have set like 30% of the in the first phase, if I mentioned like 30%, so only 30% of like only three new pods will get created, and after that old 3 pods will get deleted. In next phase, I have wrote if I wrote like 50% or 100%, then like if it is 100%, then new 7 pods will get created, and once the health API is up, then old 7 pods are where will get deleted. So these are like I could say like Canary type of deployment. Reference site to get more info about Istio or try with Minikube. You can try with Minikube, but I haven't tried with the Minikube, but definitely you can try it out with the Minikube. Yes, but Minikube looks like you can use on your laptop if your laptop is like with the full configuration, having the more resources, then definitely, because Istio is not like I am deploying only one single application. I'm just trying to explore the Istio, and if I have only one application, I'm just trying to expose it with the Istio. That is not the case. It should be like multiple microservices or multiple applications which are running inside the Kubernetes. Then only we can explore this service mesh. Yeah, I could see like most of the questions I have covered. Hmm. Yeah.
Thank you, Purva. It was really a very great session.
Yeah. Any more questions?
No, no,
If you have like more questions, you can connect with me.
right now you've covered all the questions. So it was really a very wonderful session, very informative. Thanks a lot for your valuable time.
Yeah. Thank you, Arshita. I'll stop my presentation. 1 second. Okay. Okay. Over to
So
you.
yeah, so we'll be having our next speaker, Ram Iyengar. So hi Ram, are you there?
Hey Harshita, I'm here.
Yeah. So let's have a quick intro. He's an engineer by practice and an educator at heart. He was pushed into technology evangelism along his journey as a developer and hasn't looked back since. He enjoys helping engineering teams around the world discover new and creative ways to work. He is a proponent of product development and engineering teams that put the community first. In his spare time, Ram produces illustrated books for children. He lives in Chennai, India, with his wife and 2 kids. In his free time, he enjoys taking long walks and exploring cuisines from different parts of the world. So, over to you, Ram.
Thanks, Harshita. Um, Definitely a pleasure to be part of this group and sharing some of my experiences along my Kubernetes journey and some more recent discoveries that I've made in the open source world. So, one of the things that a lot of us keep hearing all the time have to do with fancy trends and fads and other things. So um, we're used to working in a particular way, and along comes a technology that totally changes the way we've done things, and then we all scramble and try to retrofit this stuff into our workflows, or we end up discovering new workflows, newer ways to work, better ways to work. And this whole phenomena is just, I guess, repeating with Kubernetes right now. That said, all the things that we're hearing about Kubernetes and speaking to all of the people who are working with it, there's definitely so much positivity in terms of what Kubernetes is capable of, what it can provide, and how it can really transform the application rollout and maintenance and stuff. However, it comes with a small caveat. Just like we saw in the previous presentation, it can definitely be a very complex sort of beast. There's really very many moving parts. There's a lot that's going on in terms of the number of subcomponents, so to say, and it becomes very difficult given the limited amount of time and bandwidth that a lot of small teams and agencies and startups and indie developers have. It definitely puts it out of reach for a lot of these people, and that really reminds me of the of a story that we've heard as kids, where there's a fox, can't reach the grapes, and then it just walks away saying, "Oh, the grapes are very sour." So a lot of people who I have interacted with, and this is not just in some parts of the world. This is across the world. All of them would like to have Kubernetes, but they just don't have the time and the bandwidth and the energy to pursue it. So a lot of people just leave it. So my talk today is about how the open source community around Cloud Foundry has been able to create a PaaS experience for layering over Kubernetes based infrastructure, and that'll solve a lot of the problems. And it's not just about solving some of the problems that exist with Kubernetes, but it will also provide a wonderful experience idiomatically. Like the basic and the fundamental experience for developers is simplified, is better, and is just so much it makes Kubernetes so much more usable, so to say. So I've divided this talk into three sort of very rough pieces. I'd like to talk about the past for a little bit and see how we were led here. And then I will provide some details about what is the current state of affairs and the state of the union, so to say. And then we will look into the future and we will see what lessons have we learned from the past, and where is it that we can springboard from where we are at today. So here's a small history lesson for those who are interested, and it basically starts off with this pursuit of developers wanting to deploy applications but not wanting to take on a lot of the complexity that comes along with it. So there's always been a pursuit of, is there a simpler way to deploy applications? Is there an easier way to sort of maintain these? Is there some way in which we can avoid a lot of um, the toil that comes along with deploying and maintaining applications and so on. And then obviously what people were after was the ability to deploy more frequently, deploy at will, and basically go from like a waterfall model of long past to agile models of slightly more recent past, to try and deploy as many times as you want, not wait for cycles, respond to the market as soon as changes are required and things like that. So the ease of deployment was basically so that the velocity with which software got deployed could be more and could be made faster. Now, in this context, especially about when talking about the history of PaaS, it's very pertinent to mention Heroku. So, Heroku was among the first players who changed this whole game from if you have a code base and you wanted to deploy that code base, all you had to do was git push Heroku, and it would handle a lot of things beneath it. And so because of the efforts of the Heroku team, we were able to create some mainstream impression of what a PaaS should look like, how a PaaS should operate, and what a PaaS should be able to do, and stuff like that. So in my experience, at least, Heroku was among the first tools to really sort of be that game changer and be worth its weight in gold. That said, Heroku was also very expensive, and it was definitely a lot of gold for in exchange for what Heroku could do for a developer. But all of these things that we've been speaking about in terms of obfuscating a lot of the complexity, abstracting away all of the unnecessary internals, and stuff like that, the Heroku team did like a wonderful job of that. And so I think no discussion about PaaS and no presentation about PaaS is complete without taking a look at this version of uh, the stack. So this was formalized again about 8 or 10 years ago, when um, PaaS started to become mainstream and was starting to provide a lot of value in terms of what it can and cannot do. And this is basically a sort of very interesting overlay of, here's the different constituents of every single technology stack, and here's what you get in return for using a PaaS. So it helps contrast with other options that people have, and as long as developers and engineers were capable of and handling um, changes to the application in the form of code and to the data in terms of databases or underlying file systems and other architecture, things would just run smoothly. And the reason I wanted to put this was so to just allude to some more architecture blocks that will come later, and which brings us sort of to the present. So what do we have right now? So right now we have systems where source code or application code is treated as the base unit. So version control is basically used to create code base that remains as the single source of truth for any application. Code has also been able to incorporate everything from infrastructure above, and so we have new and very um, sophisticated paradigms such as infrastructure as code. We're able to containerize all of the applications that we have. Containers are again the unit of deployment for a lot of people, and so um, today right now, with Docker and with all of these things, it's just become so simple, so easy, and so straightforward for people to just pick up containers, write up a few Docker files and things like that, and start deploying applications. And so the barriers to thinking about, here's an application, here's how it runs, here's where it runs, all of these different applications, even if broken down into like microservices and use different like polyglot means to be written in, all of these can be condensed into these two paradigms. So at the end of the day, you have code, and that code has to run inside containers. So the world has become very used to this paradigm today, and the world is very comfortable in operating within this framework. And so that has given rise to this DevOps movement, so to say, and that's really caught up in the past 10 years, where um, development and operations are not necessarily viewed as two independent responsibilities. They can be done together, but that's sort of again a very narrow view of what DevOps is and what DevOps can do. So it's also more about here's a set of problems that belong to the dev domain, here's a set of problems that traditionally belong to the ops domain, and today you can count on sort of having responsibilities that span both of these areas. So there's an analogy of the blind and the lame, where a blind person can basically walk and a lame person can see, and so they just sit on top of each other and go wherever they want to, and they can get there fine. So um, it's a similar sort of situation where there's no wall across which you just toss your code and say it's an operator's problem from now on, and then operators throw tickets back across the wall and say, hey, your code is broken. So it's more of bringing in transparency to the workplace in terms of this is how code is functioning in production, and uh, the responsibility of having that code run properly and without problems is basically a shared responsibility between those who are developers who've written the code and operators who might be operating the platform, or it might be the same person, or it might be two teams, what have you. So the again, it goes back to code and version control being at the center of, or being the starting point for all of this activity, and containers being the platform operators is paradigm of choice, right? And what this has given rise to more recently is this term called cloud native, and it has been doing its round for a while, but right now cloud native is definitely on the forefront of everybody's digital transformation effort. So um, everybody wants um, to be part of this quote unquote bandwagon, I guess, but everybody wants to work with cloud native technology. Everybody, they definitely, the world definitely sees the merit and is attracted to cloud native as a way of not just deploying to the cloud, but having you know um, the even from the first stages through the pipeline and up to deployment and have all the operations all operate in a cloud first, cloud native paradigm. So that's really the definition, and that's what people are going for. So in terms of tools, what does this look like? So obviously, so just recall this slide for a minute, and I'm just trying to build a parallel there, right? So obviously, for code and version control to be at the helm of everything, the world's favorite example right now is GitHub, I guess. But obviously, there's GitLab, which is by no means inferior or anything. And GitHub is just an example. Um, there's also like Bitbucket and all of these wonderful version control tools. It's just that I'm giving an example of one of the more popular ones. And then for containers and containerization, obviously Docker is the one um, that really brought things to the forefront and made containers so easy and so accessible and stuff. Obviously, containers were around a lot earlier than Docker came along and made it glamorous, so to say. Of course, we're past the history section of the talk, so I won't get into Linux containers and how they achieve namespaces and separation and things like that. But basically, Docker came along and really changed the way people had access to containers and made it more accessible. Now, the third thing we had was um, DevOps. And so, what does tooling look like for the DevOps space? That's what it looks like. All right. So this is an image that I borrowed from the folks at the Cloud Native Foundation, the Cloud Native Computing Foundation. I'm sorry. So CNCF plays a major role in making tooling available for the people who are looking to move to or looking to operate in a cloud native way. So they have like a very robust incubation program and a graduating program, and all of these tools, I guess, are open source, or rather, a significant portion of the companies that are contributing to these also have like an open source um, code base, and there's probably other parts of each of these companies' code base that's not open source, but then whatever is accepted into like CNCF and graduates from there is definitely open source. So um, everything you want is available. So if you wanted some form of infrastructure, if you wanted some form of uh, tools to host them, to provision them, to manage them, automation, registries for your containers, security tools, orchestration tools, storage, networking, services and service brokers, all of the different databases and data and number crunching tools that you want, several options for continuous integration and continuous delivery, not to mention all of the observability that you need, and the metrics and the logging and any tracing infrastructure that you need for production are all available um, through some of the tools that are members of the CNCF. So that's what tooling looks like. And um, just in terms of sort of some non-technical statistics for about this and for the cloud native ecosystem, is there's over 1,500 um, companies and tools that are basically working with the Cloud Native Computing Foundation. Between all of them, they have nearly 2.5 million GitHub stars, which I guess makes sense to a lot of people. They're operating software that's worth well over $20 trillion in terms of market cap, and just between them, they've all managed to raise around $65 billion in venture funding. So for any entrepreneurial minded audience who are out there, just something that you can chew on. But all of that being said, right, so our evolution into the space of having code as a fundamental unit of development, having containers as a fundamental unit of deployment, um, and all of these different tools that can work with these uh, two sort of cornerstones, and work with everything in between. One thing that a lot of people have started to ignore, and not just ignore, but it's fallen through the cracks, is the whole developer experience, right? So what is it that a developer expects when working with code, and what is it that a platform operator actually needs to make sure that the software actually works, the application stays hosted, the application is functional. So obviously, it goes without saying that developers want to code. They want to pick up requirements and user stories or whatever it is that they use as they come in. They want to write code that solves the specific business problem, and they want to be focused on the domain of having code carry out all of the different requirements. Operators want a simple way in which this code gets taken and gets deployed to their infrastructure. If that infrastructure can be Kubernetes, then it's all the more uh, desirable, right? So uh, basically what they want is pick up the code that's being written. Once I'm done, once I've checked it in, once it's passed all its tests, just deploy it. So um, engineers want to write code, they want to receive feedback on in any form on the code that they've written, and they just want their code to run and work on like the infrastructure. And operators want to enable this mechanism where once you're done with code and once you check it in, then it comes back and we're able to provide you sufficient information in terms of feedback, so you can improve and make things better and process things much better with the code that you're writing. And so this is our definition and vision of the future. So engineers and developers write code, and it runs on Kubernetes without without too much complications and without exposing engineers to all of the complexities that can come with running and operating on Kubernetes. And so, in a throwback to something that a wise man once said, um, the the sort of um, deep design vision for uh, what we would like is, here's my source code. So an engineer says, or a developer says, here's my source code, run it on the cloud for me, I do not care how. So this was a famous haiku that is attributed to Onsi, who was like um, one of the chief technologists at Pivotal, which is where um, Cloud Foundry first took shape. So today, we are positioned at the Cloud Foundry Foundation. We are positioning the Cloud Foundry experience on Kubernetes. So, what that means is Cloud Foundry over the past many years has become one of the best standards for developer experience on virtual machines and VMs. And so, Bosch, which has been the mainstay of the Cloud Foundry technology, is extremely popular and helps host like trillions of dollars worth of software right now. So there's banks, there's governments, there's major financial institutions who are all working with Cloud Foundry, and there's also like tons and tons of other sort of uh, medium-sized firms, a lot of smaller agencies who operate within the Cloud Foundry ecosystem. So the success of the Cloud Foundry experience is now being ported to Kubernetes based infrastructure. So if you go back to sort of this picture, um, why I say that this is what we are inventing as the future is, the Cloud Foundry experience basically means, you take your code, check it out of version control, or once you finish development, you just do CF push, and that triggers the first step of your CI/CD pipeline. Now you might have like 5 stages before you qualify it for production, or you might have like one stage, or you might be directly sending stuff to production. So it really doesn't matter. So that's the kind of abstraction, and that's the kind of successful PaaS experience that Cloud Foundry has brought to developers. And now we are at a point where we can make this promise of a wonderful Cloud Foundry ish, Cloud Foundry ish, not ish, Cloud Foundry developer experience for your Kubernetes based infrastructure. So your basically the developer doesn't need to know what Istio is, they don't need to know what service meshes are, they don't need to wrangle with like service brokers, they don't need to know if pods are running, they don't need to manage errors, none of that stuff. So they focus on applications, on code, and they just continue to deploy, and all of this other um, management of operations is done separately on a separate thread. Now, whether a developer does it or you have dedicated operations folks, that's a completely different issue. And let's take a small dive into this project and see what it is. So the project is named CF for Gates, which is obviously like I guess very straightforward. So the Cloud Foundry experience for Kubernetes based infrastructure. um, Member organizations of the foundation who are very active contributors to this are folks from VMware, folks from IBM, folks from SUSE, and folks from SAP. So these are among the four that I can remember, and there's obviously, because it's open source, there's like hundreds of other contributors as well. Um, and one of the goals for CF for Kids is to adhere to uh, principles of the open source community, obviously, and also maintain open standards. Now, historically, Cloud Foundry, they were, um, when it was, let's say, pivotal Cloud Foundry, for lack of a better term, when they were completely owned and operated by Pivotal, they had a lot of proprietary and custom standards for um, what components worked inside. So they had a parallel to Docker, they had a parallel to Kubernetes, they had a parallel to a lot of different technologies that were already available and a lot of people were using. And so one of the more conscious decisions that the community and the foundation has taken in the past few months, maybe years, is let's reinvent the Cloud Foundry experience for Kubernetes based on a lot of open standards and based on a lot of components that are already open source and available and within the Kubernetes ecosystem, right? So that's one of the things that that we are aiming for. Another thing is, all of your applications should run using Cloud Foundry. So there shouldn't be exceptions when we're talking Cloud Foundry deployments. It's not like, oh, we'll work for like a bunch of the Java and the Ruby and the PHP apps, and then if you're using something very um, you know something like, let's say, Flask, and then we won't work for that. So irrespective of what languages your apps are written in and what your apps do, and whether they're like small apps, big apps, whether they're just services at the back, it doesn't matter. It should all function by being deployed through Cloud Foundry and onto Kubernetes based infrastructure. And not just that, it should work irrespective of which infrastructure provider and which sort of Kubernetes provider you're using. And over and above that, even if you have like a multi-cloud deployment, like let's say, for example, you have a system where all your code is on GitLab, and then your local testing infrastructure is running on DigitalOcean Kubernetes, and your production infrastructure is running on Azure Kubernetes. Cloud Foundry should be able to trigger this entire pipeline just by doing CF push on the developer's code base. So there should be no problem in sort of defining the pipeline, irrespective of any of this multi-cloud deployment that you do, or even if you're on just single cloud, just different clusters and things like that. All of these combinations must and should be and will be supported by um, CF for kids. So that's another big aim that the team has. And so now I'll break down what or how the life cycle of this entire thing happens. Um, the CF push basically creates like three distinct sub processes. And so the life cycle of an application after you push your code to Cloud Foundry is that you first receive like a bunch of build triggers, right? What we like to call build triggers. And I'll break this down. Sorry about that, snafu. And then build packs, which is a major lesson that came out of Heroku and which was developed further by independently by both Heroku and the Cloud Foundry team at Pivotal. That sort of has an important role to play in how your code is basically taken and converted into OCI compliant containers. And then finally, there is the release process where your containers are taken, deployed onto Kubernetes nodes, and the entire set of role-based access control, monitoring, and logging, and all of these get attached. Now, why all of this is important is because this stuff is required because you need uniformity in the experience for all developers. So you don't want like different commands for different languages and things like that, right? So it's not like, so in the olden days, right, Java code bases meant you need to package into like jars or vars, or and then you have to deploy into your application runtime. So and then there's different things that you did for different servers basically. So PHP code was just update the code on the server side and do like restarts, and then those became rolling restarts and stuff like that. So all of that, all of those differences in terms of build triggers are eliminated with CF push. So that is one of the aims that we had for behind, and that's one of the reasons for this design decision basically. And then there is build packs. So build packs are important because now your servers are basically getting hit with code that is in different languages, right? So build packs are required to basically figure out whatever language and runtime and framework this is, and convert that into appropriate like build artifacts and create OCI compliant containers out of it. Now, CF for Kids actually uses the cloud native build pack specification, and they make use of Paketo, which is like an implementation from VMware, specifically for building the containers and things. So there's Paketo build packs for like different languages, for like Java, Node.js, Go, PHP, Ruby, what have you, right? And then finally there is the release stage where, again, what a lot of developers expect today is they don't want to be writing their own logging infrastructure, and they don't want to be writing their own monitoring stuff. They don't want to be writing different parts for security and things. They just want one uniform thing, and they just want it to work. So the release phase is basically attaching all of these different parts to the containers that are ready to be, and deploying those containers onto like the Kubernetes infrastructure. And so if I have to break that diagram down into like further pieces, so CF push basically uploads all of the code to to what is known as the cloud controller in Cloud Foundry parlance, and then it basically triggers a build, which is it identifies, it basically tells it tells the server, okay, here's the stuff that needs to be built. Go figure out what build pack this requires, and go for it. So and then it steps into the build packs phase where the build packs detect what language this is, and so it's basically a very simple uh, detection phase, right? So if you have like a package.json, it will assume that this is okay, a Node.js code base. If you have some composer and other things, then it'll obviously say, okay, this is some PHP stuff. And if you have like Java related artifacts, then it'll obviously detect it as a Java code base, and it will use the appropriate build pack to actually start defining the container. And so at the end of this process, now there's like a handful of things that happen here, but basically what you need to know is the right build pack gets detected and an OCI container gets exported for the code that you have. And after this is all enablement of this container on Kubernetes. So the container gets deployed, containers are hooked with all of the different things, and then the routes are created, ingress and all of that gets created, load balancers and other things get configured as they're supposed to. So in terms of Kubernetes services, this is Istio, the OCI containers that are generated are loaded onto like a blob store, and then basically an engineer or a developer gets feedback whether an app has been deployed successfully or not. So um, this is sort of an X-ray view of what every individual cluster looks like. So all of these different pieces we've spoken about in different depth running up to now. But basically, um, the blocks that you see here are very specific to Cloud Foundry. Some of this is borrowed from the stuff that we were doing before and just been transformed for working with OCI containers. And a lot of these things are open source components that are available today. And so build packs can be replaced by Paketo. Blob store is basically Minio. And then for a database, we use Postgres internally. So inside the CF48 cluster, there's like a tiny Postgres that lives. And this these components basically enable your apps and services to run and operate on top of them. So this is what a cluster looks like. And external to this cluster, there's like container registries and app registries that you can also work with if needed. And obviously, external to this cluster on the developer side is CAP and YTT and all of these different tools that you might need. Now, this is a view of CF4K's networking, but I'm going to skip it in the interest of time and because I don't want to make this sound more complicated on a Saturday morning. But very quickly, let me. Do I still have time, Harshita, to go over a few things?
Yes, sure, sir.
Okay, so just 5 minutes, all right. Um, so I have a deployment on Google Cloud. It's running on GKE. So if I just open my Kubernetes engine, so this will show you my cluster that I have, and sorry, I'm logged in as the wrong person. Just give me one moment to do this. But basically, I wanted to show what my Kubernetes cluster looks like. And please forgive me for not being as prepared. So hopefully this works. So I just wanted to show how my cluster is organized, what it has, and how functional it is. There you go. So this is my cluster. I use it for a lot of demos. Basically, it has 5 nodes, each with 4 CPU and 16 gigs of RAM. Now you can see all of the different workloads that are operational on this. So every little block that you just saw before basically has corresponding parts here that you can see. So that's how we accomplish deployment. And there's also like a mini broker for services that is there. You can replace this with like any open source service broker um, stuff. So this is running, and so in order to just push an application here, all I have to do is on my command line, I can connect to this um, service and just deploy to that. Now let's see if I can do that very quickly within the time that I have. I'm guessing this is my give my typing skills. Let me make this bigger. So I'm just trying to like set my API endpoint and log in to my Cloud Foundry instance. Um, so Cloud Foundry basically has like a um, command line interface, which you can use to connect. Oh, maybe I have to log in. Sorry. But okay, I can skip that. It's a few steps, but what I'd like to emphasize to people, and let me like show a few things before that. So um, we are at all of this is at github.com/cloudfoundry. So just look for the CF for Kates project. That's our open source. I definitely encourage you to give us a star while you're here. Um, but I don't think we are on Hacktoberfest, so please spare us some of the PRs. Um, but this basically is a great starting point for trying Cloud Foundry out. Now there are some publicly available Cloud Foundry providers, but they do not deploy to Kubernetes as far as I know. So they're all just like cloud providers. So definitely attempt to deploy this on your own infrastructure. We have very specific instructions on our Medium blog. So you will recognize my face and one of my colleagues. Both of us, try to break down a lot of information that you need to deploy Cloud Foundry to any infrastructure of your own. So there's stuff for Google Cloud and DigitalOcean on there. Azure will be up next week. I know it works for a fact. Kind clusters are also rather kind to us. So if you want like local deployments, do try on kind. I haven't yet tried on Minikube myself, but I've heard people in the community have been successful. So that's another place to try. And AWS has a few wrinkles that we're still ironing out, but we should be able to do that soon, I guess. Right? And obviously, for whatever pull requests or feature requests that you might have, definitely try and contribute to those either by yourself or give us enough information so that we can pick up the stuff that you really need and stuff that makes sense, and try and include that to future releases and versions. Cloud Foundry folks are available at Cloud Foundry on Twitter. So if you have any questions or if you need any kind of support, definitely reach out. The best place to reach out though is our Slack community. So please, 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 if you've not already joined in the past, I would definitely encourage you to join in future. We have a wonderful community of people who are very happy to help other folks, and they definitely respond on time, and they're very patient and welcoming. So definitely join the community. The channel that discusses CF for Kate specifically is hashtag CF for Kates, obviously. So you'll find a lot of people who are getting started, who are experienced in all of these things there. So you can get a lot of clarification. I showed you the GitHub page already, so you can go ahead and get started with that. So thank you once again to all the organizers. I'm sorry that I couldn't like do a full demo of what the experience is like, um, but for those who are interested, there's a lot of information on the Medium blog and in a few other places. And if you care to follow me on Twitter, I can share that information with you as well. So yeah, thanks once again for your patience in listening and joining on a Saturday morning. And thank you to all the organizers as well for having me.
Thank you, Ram. There are like few questions that people have for you. So the first is, in which language Cloud Foundry is written? Is there a particular language in which it is written?
So there's been some stuff that has been done historically, but right now a lot of the stuff that we are doing is in Go.
Okay. What are the different services in Cloud Foundry?
So if you mean like different databases and things like that, um, Cloud Foundry provides service brokers to which you can obviously attach any service that you want. But out of the box, you get Redis, you get RabbitMQ, you get MySQL, you get Maria, you get like a MongoDB, and all of these different things.
Okay. What matrices and logging is used in Cloud Foundry?
Kubernetes has a native metrics server. So, CloudFound CF for Kates makes use of that. And there's also like a native logging capability that's available. If you want to externalize your logs and things like that, there's ways to use Elastic and deploy an ELK. There's also people who've had some success with Fluentd. So it really depends on what your workflow is, and you can either make use of something that's built in, or you can externalize and use external services.
Okay, last one. What is the minimum requirement to try CF with low cost? Any suggestions?
Right. uh, so, like I mentioned, it works on kind clusters. Um, some people have tried it with Minikube. But the best suggestion that I probably have for you is sign up for a free account that gives you like $100 credit on either DO or Azure or GKE, and just work with that. It works on all of these, and I've tried it. So um, the documents do recommend 5 nodes with 16 gigs and 4 vCPUs each. I have had success in installing it with 3 nodes and with 2 nodes as well. So all of those definitely come or are well within like a free plan. So I would definitely recommend trying out all of those options.
Okay, thank you. Thank you, Ram. It was a great session from you.
Okay, thank you.
Okay. Now we move on to the next speaker for the day. It's Ajit Singh Raina. Ajit is a Docker captain and Docker community leader for Docker Bangalore. It is one of the largest meetup in the world with nearly 12,000 plus members. He is also an ARM innovator and a prolific blogger, and have over 230 plus blogs around Docker, Kubernetes, and cloud. His personal blog attracts roughly around 40 million visitors per year. He runs Collabnix Slack, which holds currently 4,700 plus members. He's working in Redis Labs as Developers Relations Manager. Earlier this year, he bagged the Docker Community Award by Docker Incorporations during DockerCon. Last year, he was recognized by his fellow captains to receive the Tip of the Captain's Hat Award for his tireless dedication to sharing his expertise with broader tech community. I'd like to welcome Ajit. Ajit, over to you.
Thank you, Sarvesh. Can you hear me?
Yeah.
Okay. So thank you everyone for being with us today. And I hope you are having an exciting day today. I have one of the most exciting topic which I'm going to talk about, which is all about quantifying your world with AI and Docker on the edge. So let us get started. Okay, a little about myself. I am a blogger at Collabnix. Collabnix is my personal blogging site, and I have been writing since last 5 to 6 years. I have around 200 plus blogs which I have written around Docker, Kubernetes, and cloud. So do visit it. You might find it useful. I'm also a Docker captain. Right now, I'm working as a developer relations manager at Redis Labs, where I'm helping Redis developers with the contents, more and more contents around the Redis enterprise as well as open source. I'm also a Docker Bangalore community leader. We have around 10,200 plus community members in Docker Bangalore Meetup group. And we have been conducting Meetup all across India, especially doing it as a virtual conference. I'm also a part of ARM Innovator, which means that I work very closely with other 50 plus ARM innovators and try to see how we can go ahead and contribute in terms of AI, Docker, and edge devices. I worked in the past with the companies like Dell, VMware, and CGI. Okay, so today agenda would be roughly something which rotates around AI plus Docker plus IoT. So I will start my session with talking about benefits of containers for AI adopters, because since AI is a computer science branch which talks about how you can build a smart machines using a human intelligence, right? So, but why containers? Why we are talking about containers here? Why we are talking about IoT here, right? And what is the relationship in between containers, AI, and IoT? And then I will talk about a few of the very interesting facts around the newly launched Jetson Nano 2G board, which cost around $59. So I am going to talk about its deep learning stack, GPU support under Docker 1903. If you are quite new to the Docker, this would be interesting for you. One of the interesting tool which I have been exploring and I have been contributing directly and indirectly is Open Data Camp. So I will show you a cool demo around it. And then I have two demos to showcase how the deep learning, AI, Docker, IoT comes into the picture and how you can build an exciting projects around it. So this agenda will definitely be, it will excite the audience, especially the college students as well as the DevOps engineers who wants to pursue their career in cloud native application on top of IoT platform. Okay, so what AI plus Docker plus IoT has to do here? So let's cover the first two parts, AI and Docker. Benefits of containers for AI adopters. So let me take you to one of the report from 451 Research. So this is basically this year they went ahead and did a kind of a research across how the containers have been used for the AI platform. You will be surprised to know that around 94% of AI adopters are planning to use containers. Now, this is something really amazing because containers has been there for some time, right? There are container workloads, but think of CI/CD platform running on our IoT devices like Raspberry Pi, right? That sounds really interesting. The more interesting fact here is all of those factors: increased portability, easier management, improved resiliency, developers productivity, faster time to deploy. These are the reasons, right? These are the reasons why we are talking about containers on IoT. If you look at Docker as a platform, it is an Docker is an open platform which helps you to build, ship, run and share your workloads, right, in the form of the packages. And that packages, no matter if it is a bare metal or on the cloud or an IoT device, right, that packages from your development to the production has to accelerate the whole software life cycle development, right? So we are talking about a DevOps model. So these are basically the factors, and based on the survey, what they found that, is, if you look, 14% believe that containers can be used on IoT devices or can be used for AI for the faster time to deployment. So these were the facts which which I thought about, and then I thought that, okay, let's come up with something exciting around it. Now let's talk about AI and IoT, right? Why should I really care about IoT? Now let's go back and try to see, try to look at the connected devices per person. Okay, if you look at the world population at this point of time, we are at 7.8 billion, right? That's used. And then in next 4 years, we will be crossing 8.1 billion. Now let's look at the connected devices. In connected devices, right, at this point of time, we have it's not a billion, it's 8.8 connected devices, right, which will be having per person. Like the connected devices in terms of per person, it will be 8.0. So which means that at one point of time, you will have 8 devices with you, like a mobile phone or in the form of the smartwatch, right? These are the connected devices which you will be having, right? And that could be a medical equipments also, which you carry all the time, right? So those devices are going to surpass the world population. Look at the connected devices as 13.5 billion connected devices you will have by 2024. So that's the reason why we are talking about IoT. That's the reason why we are talking about how the uh, DevOps model or CI/CD model or faster time to market, right? So to enable the faster time to market, why we need those devices to run our workloads. Now, if you look at IoT infrastructure, especially the IoT boards, at this point of time, we have these popular boards like Raspberry Pi, uh, NVIDIA Jetson, and then Banana Pi, Arduino, Orange Pi, right? So these are very tiny devices, like a credit card size, where you can run your workloads. And these workloads could be an AI workloads or any kind of a workloads which you think can collect the information from your site. If you are a farmer, you can use the device to know the moisture of the soil. Based on that, you can go ahead and do the cropping part, right? If you are the person, if you are an authority which wants to track the traffic signal, you can have these devices installed on the traffic signal to see which vehicles are following the rules or not. So there are multiple use cases which comes in between. And one of the device which I was really excited about, and this was launched just 3 to 4 days back, was Jetson Nano 2GB. So these are the devices which cost around $59. And one of the exciting features which these devices brings is the GPU. So you now have a GPU card inbuilt into these devices, which means that you can run any kind of a uh, deep learning workload on top of it. Look at the specifications. These specification, if you look at the specs, it very well matches with what you have in your mobile devices or you have on a server. Especially 128 core NVIDIA Maxwell. This is a GPU device where you can go ahead and train your deep learning model. That is something, because CPU alone can't do it, right? You need a more and more processing which has to be done, and GPU does that. With 4GB, you have especially the 4GB memory, but with this 2GB model, you just have a 2GB 64-bit LP DDR, and then it comes with it is basically a kind of a laptop. It has USB port, it has HDMI port for your display. You can connect any wireless dongle to it and then start working on it. And it comes with a Linux distribution as well as Windows IoT, which you can run on top of it, right? And these, all the operating system, like whatever the operating system you want to run, runs on the micro SD card. Now look at the way how you have been using these kind of a devices for running an AI workload. Now, if you look at the stack which is provides, especially I'm talking about NVIDIA Jetson here, because this is one of the device which is quite exciting for me. If you compare to the Raspberry Pi, which doesn't come with a GPU, right, in the 2 GB model, but in this, you have a very strong CUDA stack, right? The CUDA stack is for the parallel processing. For a deep learning or AI model, you need such kind of, powerful devices. And CUDA is one of the parallel computing, CUDA provides you with the parallel processing altogether. And look at the modules which you use. OpenCV is one of the computer vision model, which is free of cost, or it is open source. You can go ahead and use it. TensorRT is one of the AI module, which you can go ahead and integrate with a lot of AI workloads. OpenGL, Video API. So these devices basically comes with a jetpack, which has all the necessary stuff which you need to implement a deep learning platform. And that is the reason you don't have to spend more and more time in building your own deep learning model. These models come shipped with these devices, and you can go ahead and get started with it. And then you have a gesture recognition, object detection, analytics. And during the course of time, at the end of this presentation, I will show you how you can go ahead and do a deep learning based on these kind of devices. Okay, so what happened when AI, Docker, and IoT come together? So now this is an exciting part, and I'm going to, I'm sure you will definitely like this. Okay, I'm going to introduce a kind of a tool called as Open Data Cam. So if you have a Jetson Nano with you, this is a tool which is basically ready to go tool. You just install it in terms of Docker containers, and that's it. So let's talk about Open Data Cam. Now, Open Data Cam is basically a GitHub repo. If you go to github.com/opendatacam/opendatacam, you can see the whole description, which is written in very nice way, and the detail. And so basically it is a 100% open source solution which you can use it. It quantifies and tracks the moving objects. As I said, right, AI is that branch of computer science which helps you to build a smart services. And this is one way where you can go ahead and even build self-driving cars. So this could be one of the solution which you can use, especially the payload. I am working in one of the project called CherryBot, which is a self-driving robotic platform. So most probably these kind of solution will definitely help you in tracking the objects and making the machines more intelligent, where you can do whatever you have been doing, right? You can make machines work in the same way. And it runs only on Linux platform. Since Linux is very popular and it is robust, right? You can go ahead and scale it. So that is the reason you have one more benefit of running Linux and CUDA GPU. So you don't have to build something from scratch. The other thing is Open Data Cam supports Docker container as well as K3s. So if you want to run an Open Data Cam on Kubernetes platform, you can still do that. So usually we don't run a full-fledged Kubernetes on IoT device. We have a very tiny version of Kubernetes called as K3s. Okay, so infrastructure setup for my demo would be more like an NVIDIA Jetson Nano, a kind of a webcam Logitech, right? So for this demo, I picked up one of the file which I am going to insert into it, and I will show you like how easy it is to just, if you have a video, you just put it in the browser and the deep learning, you can get started with the deep learning. So, and that can be accessed through your smartphone. So what makes Open Data Cam so robust? It is basically a GPU support under Docker 1903. Since the Open Data Cam runs on Docker, or you can run it without Docker also. But if you want to get started in just 5 minutes, you can go ahead, you can pull the Docker image and get started. And 1 year back, I raised an issue about Docker Compose support for NVIDIA Jetson. Like, if you are running a container, it is okay. But if you want to use a Docker Compose, then most probably you need to basically install an NVIDIA runtime container on top of it. So there is a workaround for it. So this is one of the bug which one of the issues which I raised, and it has already crossed around 150 plus comments. But I'm happy that right now we have some kind of a workaround around it. Okay, so if you see this particular command, like docker run ---- GPUs all, that's it. You need just this option to basically leverage your GPU. So whenever you run any Docker container, right, there has to be some kind of a workload. So for Open Datacam or NVIDIA SMI is the command which helps you give all the NVIDIA GPU information from your system. So you can just pass ---- GPUs, and that's it. You can go ahead and there is an option where if you have more than 2 GPU card, you can just go ahead and specify, okay, I need only 2 of the GPU card to be leveraged. And the same command runs over the cloud itself. When you create an instance with a GPU, you can run the same command, and you can expect the same kind of a performance coming out of it. Now, how shall I run Open Datacam? What are the options I need to take care? So first thing is you need to make changes in daemon.json file, which is under etc docker. And then you have to specify this runtime. Just yesterday, I came to know that you don't need to do this with the latest Docker Compose version, which is 1.27. This comes by default. This feature comes by default. So I really need to go back and check this. But at this point of time, if you are using earlier version than 1.27, right, you just have to go ahead and make this entry, and don't forget to restart the Docker, because daemon.json gets reflected only after the restart. And then ensure that you have NVIDIA container runtime package to be installed, and that's it. You just clone the repo and try to run install opendatacam.sh and platform nano. So let me show you a quick demo around it. So okay, so what I have done here is I have a quick recorded demo. So I will go through it so that I can get some time in showing you. So at this point of time, if you see, I am on Jetson Nano board. You can see here the architecture of this particular system. I have Docker 1903/06 running on the system. So right now we have 1903.12, but it should work because GPU support is starting from 1903 version. So we are good with this. So what I have done is I have cloned the Open Datacam repo. So what you see here is basically Open Datacam repository. Under that we have a Docker, and this is a specific script which will bring up all the containers. At this point of time, Open Datacam is supported on Nano, Xavier, and TX2 model of NVIDIA Jetson board. And these scripts all talk about, it uses a Docker Compose in between, and then it try to bring up all the microservices. So if you are new to Docker Compose is a tool which helps you to build the microservices. And you can also use Kubernetes, right? If you want to run on top of Kubernetes, you can run it as in terms of pods. So let us go started. Let us start this particular script and specify the platform. So we have a platform called Nano, and just wait for, so you don't really have to wait a long time here. So if you go to this particular link, you can see here that Open Datacam initializes. So behind the scene, it basically uses the MongoDB and then the YOLO framework. So YOLO is a framework which basically, with the help of OpenCV, it helps to go ahead and you can do a kind of an object detection analytics implementation on top of it. And within few seconds, you will see that you will start seeing that YOLO gets initiated. And there is a video file which I have inserted into it, which is basically a kind of the traffic, right? And you can see here how your Open Datacam recognizes the objects as car. Whatever the percentage you are seeing is basically the accuracy and the probability. So Open Datacam also try to classify the objects. So you can see whether it is a car or it is a person. Now, one of the really fascinating features which Open Data Camp comes with is you can set up the direction. So say now the vehicles are staying at the traffic signal, and I'm just trying to see how many devices or how many vehicles crosses this particular path. So if you see here in this traffic signal, I have till now 5 of the vehicles which has crossed. And also I can see how many cycle, how many other vehicles, other type of vehicles are crossing it. If it is a truck, so at this point of time, we just have 14 cars which have crossed it with no person, no bicycles or any other type of vehicles. So based on that, I can stop it anywhere and try to reset the direction. Whole of this information can be stored in the form of the JSON, and that is something you can store it in database for further analysis. But look at the objects. Right now there has been around 230 plus objects which has been tracked, and I can go ahead and make the changes in terms of the counter. This is a path finder which shows you like which is an optimal path for a vehicle to travel, right? So you can see here the traffic light is on, and the left side vehicles are now moving. So you can see that the pathfinder automatically gets added to it. Okay, now this is interesting. Let me show you next interesting stuff here with one of the other demo which I wanted to show you here is whatever I posted yesterday over the YouTube if you are in the Slack channel. So take an example what you can do with it. Yes, object detection analytics is good. You are able to track, but what about the self-driving car? Now, this is one of the video which was uploaded some times back, where through the deep learning platform, you can go ahead and operate you can enable a solution like self-driving car. So at this point of time, a person is looking at the mobile and is tracking. He's setting up the destination here, and you can see a lot of box here, which is basically specifying. If you look it closely, one of the truck is coming in front, so it has detected it as a truck. Using a counter, I can set it up like how many vehicles I can see, I can track, and based on that, the vehicle can move without any obstacle. So at this point of time, if you see here, I have made it as a bidirectional, which means all the vehicles moving to and fro, which is moving from in your front, which is coming towards you or far from you, you can track that. So at this point of time, it is able to detect the 6 of car which are standing in the traffic signal, and now the vehicle starts here. So you can see here, we are not controlling the steering. It is controlled by itself, and based on the deep learning platform, it is looking at the obstacles, how the vehicle is moving, right? Now look at the way the objects have been detected here, and based on that you can count how many objects are there. So it might have detected one of the bicycles which you see on the right hand side. Most probably based on that, it is the vehicle is getting controlled. Okay. The data which you collect here, right, that can be used for a lot of analytics works for sure, in order to see, like, look at the counter, look at the objects it is detecting at this point of time. There are 2 bicycles which it has detected. And especially when you see these devices, right, these devices have some kind of a probability stuff, like it might detect it as 90 or 95% of it, because the model is getting trained by itself. The next time it sees bicycle, maybe the first time it will be like 75%, the next time it would cross around 90%. So you can see a diversified objects in front, and based on that, the vehicle is being controlled. And you can also see in the console, like how the messages, how the YOLO is doing that, because the whole idea is, there will be one of the session which I'm going to talk about, the Redis AI, which what it does is basically there is a tensor data types, right? And these all images which is being captured by the camera which is connected on NVIDIA Jetson. It is capturing it, and it converts in the form of tensors, which are like a 2x2 or 3x3 matrices. And based on that, you can build your own model. So maybe in the near future, I am going to deep dive into it, and then most probably help you understand like how you can build your own model out of it. Look at the pathfinder. It has like whatever the turns which you have, what is the optimal path which you have, it is basically going ahead and trying to identify it. Okay, now this sounds good. Let me go back. Okay, so if you want to learn more about Open Data Camp, so I can show you basically the GitHub repo here. So this is a GitHub repo where it shows about how you can go ahead and quantify the world. And there are a couple of examples which you can see here. Basically, it is targeted for the NVIDIA products, but if you have any other device with a GPU, it will surely work. And you can see here the software prerequisite for it. So ensure that you follow all of these things. If you open this, one of the issues which I raised, which I was talking about, is NVIDIA. So this is one of the issue which I raised, and there has been around about, you can see here, 153 comments. I am working very closely with the Docker team to see how I can go ahead and have this particular feature enabled. And we really need to go ahead and put it in the release note. But look at the comments here. And if you go to, there has been a few other comments on how you run on EC2 also, right, which requires a GPU. So do look into this particular issue, we'll get to know. And these are the steps which you need to follow here. Even if you want to run it for a multiple platform, you can run it. And if you have a Pine 64 laptop, which is around $200, which comes with the ARM architecture, you can also go ahead and install it. Especially on the Kubernetes side, you can use K3s. You just install K3s. So you don't have any dependencies here. You just run this particular command and the Kubernetes get installed on your IoT device. You can try it on Raspberry Pi too, but you won't be able to leverage GPU on top of it. So if you have a USB camera which is connected, you can always go ahead and use this particular, you can activate this directory, dev video, and that should be helpful for you. And these devices works over a Wi-Fi. You can always go ahead and try to check this particular, and we do have an API documentation also. So I think I am pretty much done. Is there any questions? I would be happy to take it up.
Yeah, Ajit, there are a few questions. So the first is like, can you please provide with a scenario where we can use GPU with IoT devices?
Okay, so if you look at one of the example which I showed you, right, this is for the deep learning platform. Your CPU can't go ahead and expedite or accelerate your processing power. So the simple example which I showcased, the object detection and analytics, think of it as like in a COVID situation, if I want to know how many people are wearing masks, right? I can have a Jetson board and connect a connect a camera module and put it in one of the place, and where I can go ahead and identify it. Now when you have a huge amount of data and you want to process it in a couple of hours, you need GPU for that. So any AI workload will require a GPU for the faster processing.
Okay. Next is how to use Open Data Camp without Docker.
So can you see my screen?
Yeah.
Okay, so if you go to this GitHub repo, there is a section where it says you can use Open Data Camp without Docker. So just follow these instructions. Okay, and it's all about, you have to manually install it. Maybe you can open the Docker Compose file and look into what content it is, but definitely this explains about how you install the darknet, how you go ahead and specify a few of the OpenCV, CUDA and GPU related stuff. If you want to use, if you have multiple GPUs, you can specify the variables accordingly. For TXT, Xavier, so these are the steps which you need to follow.
If you are literally worried about the performance, definitely you should try it without Docker at this point of time. But if you really want to test drive or get started, I think Docker would be the preferable one.
Okay. The next is how to create or update a Docker image for Jetson device.
Okay, so if you go to this particular repo, right, you can just go to since this is an open source version, you can look at the Docker file, Docker compose file, which is itself in the code. So let me show you here. Okay, if you go to the Docker folder and then you try to go to the build, okay, let me pick up the Jetson, and then most probably you can have all the base images, how they have been built. So this is a Docker file which has been built, especially picking up the base image as Balena lib, and then how you go ahead and copy all those necessary Debian packages and how you install it. So looking at the Docker file, you can always go ahead. So say if you want to use a kind of a very latest version of OpenCV, definitely you can go back. So right now the OpenCV latest version is 4.4. You can go ahead and change this environmental variable to 4.4. Ensure that you have a specific version of OpenCV selected here, and then you can build up the Docker image.
Okay. Thank you, Z. That was really some future stuff going around over here with OpenCV using, automated vehicles and everything. An interesting session, to be honest.
Yeah, thank you so much. Thank you so much. And definitely, if anyone of you who would like to collaborate, I am working right now on a payload robotic platform called Cherrybot, which is basically a self like an autonomous robot which will deliver the swags, and you can even think of it as like a robotic platform which does the work with the Swiggy people do that, does in the same way. So you can deliver the swags, you can deliver the medicines in the hospitals, and also I'm working on that. If anyone is interested, do ping me in Slack channel, and definitely we can go ahead and see how we can go ahead and collaborate around it.
Okay. Thank you, Z.
Okay, thank you so much.
Moving ahead, our next speaker is Divya Mohan. Divya is an active contributor to various FOSS projects like Kubernetes, Articulus, and Litmus Chaos. Divya is passionate about great documentation. She is also on the Google Season of Docs program this year, with CERN and on Premier cohort of the AWS Community Builder program for mobile and web apps. A SRE and FOSS enthusiast, she is passionate about community-driven initiatives and technology bringing people together. Currently, she is based in Pune and works with HSBC as Senior System Administrator. In her spare time, she loves reading books, finding productivity hacks, and happens to be a cat person as well. Divya, over to you.
Thanks, Sarvesh, for that wonderful introduction. I shall just be sharing my screen.
Sure.
Is everybody able to see my screen right now?
Yeah.
Okay, cool. So, hello everyone, and thank you for taking out time on Saturday morning when you could be Netflixing and chilling. Hope you're all well in these super strange times when we have to be working from home and surviving a pandemic. I'm super grateful to all the organizers and the team behind OSCONF for having me on board, and I'm absolutely excited to be presenting about becoming a FOSS contributor. So today the topic is about how to get started with open source contributions. And before that, I'd like to take a quick moment to talk about myself, because not many of you all know me. So I'm Divya, and I work with HSBC as a Senior Systems Administrator. I'm a Premier cohort for AWS Community Builder, and Most of my day job is actually far removed from cloud, and it involves troubleshooting and fixing issues with middleware systems and contributing to or leading process initiatives that help improve the efficiency of how, as a team, we respond to such outages. Like Sarvesh said, I am super passionate about great technical documentation because that's something I think we actively lack. I serve different open source communities, and most of it is there on this slide, as Sarvesh has mentioned before. So I also work with CERT to manage their documentation management system as part of Google Season of Docs this year, and that particularly stems from my love for words and love for great documentation. Coming back to our agenda for today, I'll be walking us through what are the origins of open source software, why is it suddenly becoming so popular, some challenges that communities and projects that are classified as open source software face, and as an individual who is a computer engineer, an IT engineer, or actually anybody, what do you need to be knowing before you start contributing to something that's open source? And lastly, I'll just touch upon how and where you can step in, and leave the rest of the session for Q&A. So whatever questions you might have, please reserve it for the end of the session so that I can take them all in one shot. That being said, the first topic of the agenda was the origins of FOSS, or what exactly is FOSS. So FOSS or FLOSS, however you choose to refer to it, is free and open source software. And what does that actually mean? The software that falls under this category is licensed to be free in terms of using it, modifying it, and distributing it. One of the first of such licenses, open source software license, was the GNU Emacs copying permission notice. The GitHub link for this is there on the presentation. I will be uploading the slides on my personal website as well as on GitHub, so you can take a look there. Now, even under this whole open source ecosystem, there are two types of licenses. One is the permissive license and one is the copyleft license. The main distinction between these two licenses is the fact that they are restrictions on the way you distribute the software or the open source product post adoption of the product at your end. So further illustrating what I just meant, we'll take the Apache 2.0 license, which is used by very, very popular open source project, Kubernetes, which also happens to be one of the projects I work on. So an Apache 2 license basically permits whatever modifications of Kubernetes that a company or particular individual makes to be supplemented with their own copyright terms. So basically, the Apache 2.0 license has a particular set of terms and conditions in its copyright. You can add on or modify the contents of that copyright per your requirement. That is one example of a permissive type of license. Another one is the copyleft license, in which you're not allowed to do this. Basically, what happens is that once you adopt that particular product or software, you are required to reach out to the licensor for the license conditions and terms. who exactly does this bit of shipping and maintaining. So with respect to that, in the FOSS project, it is the community that contributes to the FOSS project that actually ships, maintains, and regulates the content of the code. In a FOSS project, anyone can access the code, they can update the code base, they can dip in and dip out basis their interest. It is not absolutely essential that you contribute to it or you don't. But all of this, hello?
Yeah, the way your screen is not visible.
Okay, yeah, sorry.
Sorry to interrupt you.
Yeah, not a problem. Sorry. Better now? Sarvesh, better?
Yeah. It's okay.
Thank you. Thank you for flagging that. So, so I was saying that, just a second. So, so in case of a FOSS project, literally anybody out there who wants to contribute can contribute. And most of the projects or the software are maintained, regulated, and shipped by community contributors who are doing it voluntarily and not out of any specific interest, specific end goal rather. Now, how does this happen? It's mostly via version control systems such as GitHub, GitLab, to track the contributions, because obviously since it's open source and since so many people are contributing to it, there is a possibility that there is a possibility that a lot of people can change the code for a malicious intent, and we don't want that. So a version control system such as GitHub, GitLab is used to track the contributions in case of an open source project. Now, coming to why it's suddenly becoming a popular term, one of the reasons for popularity of FOSS projects and products as a whole is because industries and folks in the IT industry in specific have started to realize that as technology advances, they don't want to be locked down to a particular proprietary product with respect to licenses and or a particular company. So not to say that an entire industry is swearing off proprietary software, it's far from that. However, companies have realized that it's very important to have a good balance between proprietary and open source software in their IT ecosystem. Also, with open source software being community driven, there is a lot of transparency on how the code is because of accessibility. So it's out there for everyone to see. And the basic difference is that it's not being written and privatized by a small set of developers in some companies. There are also additional benefits like lesser time to market and lower initial costs. Obviously, lower initial cost is a no-brainer because community driven and because free open source software. The name itself has it. But these are some of the benefits. Now, while these are all benefits, they also have a flip side, which doesn't look as pleasant. For lesser initial costs that we are talking about, we have very limited support because it's community driven. Given that most of the contributors are not permanent employees, so to say, there's limited support around the way we actually have an open source product shipped, released, and maintained. But times are changing. A lot of people are literally taking interest in contributing and in and in developing products increasingly that are open source in nature. And one of the major things that I would like to talk about is the sustainability from a product and a project perspective. So from a product perspective, open source software is really it's lower on the sustainability end, partially because of all the features that benefits that I talked about before. The ecosystem is purely voluntary. It is not something that is on a full-time paid basis. So there is interest, of course, but very little, and we're looking for more folks to join in on the movement. So the sustainability factor comes in very high when we are talking of having projects or products that are open source. And of course, since it's developers that are actually developers or ops or whoever, technical people who are contributing to the open source project, there's definitely an ease of use factor that comes across as a challenge when you're taking your first steps in the in learning the product. So ease of use is from an end user perspective, and that is one challenge that we are actively looking to overcome in many open source projects. And I think a fair amount of it has been overcome, but we still have a long way to go. Now coming to the actual meat of the presentation is how you get started, because all of this was theory, but how do you actually begin to contribute to open source? And before you begin, what are the things you should know? So before you begin, please ensure you have the bandwidth and the permissions to get started. Permissions not in the sense that you have to go and ask your parents about getting started. That's not the point. But if you are employed with a particular employer, there are a lot of companies that have non-compete agreements wherein they do not encourage voluntary contributions to projects outside the company. So that's something that you have to be extremely careful about. It could land you in a mess. Other than that, you have to ascertain the areas that you are interested in, because I personally believe that not every open source project has to be full of technical people, and nobody has to take care of other stuff. So I read a brilliant article on Farnham Street the last weekend, wherein he beautifully shared this in a quote that not all companies need to be hiring geniuses, because if everybody has a genius who's actually going to propagate the news that the particular product is out there invented by this particular genius. So I'm not saying that you do not have to contribute in a technical way, but even if you are a non-technical person and if you have very basic knowledge of the technology, it should not stop you from taking that first step. The entry barrier is pretty low, and you should definitely take advantage of the fact that that entry barrier is low for you to enter and start contributing. Once you ascertain in what capacity you can contribute, and you've ensured that you have the bandwidth, narrow down the projects, because there are a lot of them in this ecosystem. You have Kubernetes, you have hoteliers, you like those are projects I contribute to, but you have a lot of projects that are there in the ecosystem. Ascertain which one you want to contribute to, basis your interest areas and your strengths, and reach out to community members via Slack, Tech Twitter, LinkedIn, IRC, GitHub. So that is one thing. Then once all of this is done, you take the first steps. How do you actually get started? Because that's the crux of the story, right? Because I have all the time in the world. I don't know what is the first step to be taken. So the very first step would be to navigate to the project's website. All the open source projects have a website wherein you can have a look at the contribution guide, you can have a look at the documentation, you can see what is there on their GitHub or on their respective version controls. You can also take the very first steps by actually speaking to folks involved in the world on Twitter or LinkedIn, because those folks are very welcoming when it comes to a community of open source enthusiasts. So everybody is helpful when it comes to getting a newbie on board. So please reach out. You can also join in on discussions on their respective async channels, which is project. There'll be a Slack for each project, IRC, Gitter, Discord. Every project has different communication channels, so log on to that, speak to them. You can also have a look at their community calendar. So projects that I'm a part of have meetings wherein specific interest groups meet up on specific weeks of the day. And we're always interested in getting new contributors on board and having new contributors join the call. So because I know that there is a disconnect in terms of how we onboard new contributors, so that to achieve that we have calls for each of the special interest groups that for the communities that I'm a part of, and you can just have a look at our community calendars. The community calendars again are available on the project website, or at least a link to that is available on the project website. Of course, when you get involved in community calendar, when you navigate to the community calendars, normally there are also other groups or mailing lists that you have to become a part of. So that is one thing again that you could actually do. So Google Groups is just one thing that I mentioned, but there are mailing lists, there are other things that you can become a part of. And last, but I think this is the most important given the theme of this conference and given the month we are in, Hacktoberfest. So I'm aware that there has been a lot of controversy surrounding Hacktoberfest this year with a lot of spammy contributions. But please, guys, do not do it for a T-shirt or a swag material, because that really is not the point of this all. It's about sharing and learning from experiences of developing a product. It's not about getting swag. So Hacktoberfest is one of the best areas that you can contribute to, and you can gain experience via contributions and possibly join the respective organizations, and maybe take it forward from there. But given everything, the first step to be taken is with intent and not with some end goal in sight, because obviously there are benefits of joining the community, but it should not be the end goal that is always in sight. It should always be the intent of contributing and intent of sharing and developing and learning that should be the primary focus in a contribution journey. So that's it from my end. Any questions that you might have, I'm willing to take them.
Yeah. So the first question is, like, if someone is a Python developer, so like if they want to join any of your projects or any of your team members in any of your projects, so how they can be a part of your projects?
So the best way to get started is via the explore section of GitHub. So if so let me just share my screen once. So are you guys able to see my Chrome screen and not the presentation on? Yeah. So so I have a start topic that is Python, and I have this very weird habit of going on GitHub and searching for things in the explore section, and really that's a very good way of understanding where and what you could contribute to basis topics that you've started, or repositories that you've started, or repositories that you've actually viewed. So you could do that, or else join the conversation on LinkedIn or Twitter, because there are a lot of folks who are who are Python enthusiasts, who actually are interested in in building a community. So there was a recent Python conference that was held, I think, last week or last week. So attend such conferences, go to meetups. You will learn from such interactions where and what you can contribute to. So when I started off, I personally had only Kubernetes in mind, because my company was starting its journey in Kubernetes, and that's something that I wanted to gain proficiency in. I'm still learning. We have like not subgroup, I wouldn't say subgroup. We have stuff that works and is being developed in Python, but there is no specific thing that I can recommend. You have to go through repositories and check out basis your interest. Does that answer your question?
Yeah, that would be great. The next one is, if someone has no idea about what path to follow and how to exactly start, so what should they do?
So, as I said, first you need to narrow down your strengths. So my strengths were basically that I knew a bit of HTML, CSS, and JavaScript. I worked on bettering my skills and then started contribution to the Kubernetes documentation. Once I contributed to that, I applied for being on the release shadows, on the release teams as a release shadow for the 1.19 release. So the journey is not really straightforward. You have to experiment basis what you already know. So you must be having some sort of skills, I'm sure, as a student, as a professional, whoever you are, I'm sure you must have some sort of skills. So basis what you know, take that strength and see where you can contribute by joining in the conversation on various platforms like Kubernetes, Ateliers. All of these have conversations going on in their respective async platforms and in their respective async communities. So we have mailing groups and lists and all of that. So you can join in there and speak and understand. And every channel has this general channel, or Indian channel, whatever place of the world you come from, that channel specific to that location, to speak about and understand what you can contribute to. So yeah.
Okay. Next is, like, what are some effective tools of building a community?
So one of the most important tools are people. That's obviously a given. The second effective tool is communication. And a lot of it. Like, a lot of communication is required for effective building, maintenance, and running of the community on a daily, weekly, monthly, yearly basis. So that's something that I think is important, communication. And when you're talking about community, you also have to have some sort of great governance policies in place initially, so that you can have a firm base upon which to build up on. You cannot have any you can't just start up from zero without any context, right? You have to have something that you can build up on. Even though you're coming together for an end goal, you need to have something that something as a base that you can construct a community on. So governance policies is another thing that I think is a very important concept. And fourth bit, I think documentation, but that I guess is very personal, because I think having documentation, having around how to maintain, how to upkeep, how to contribute is absolutely essential. But that could be just me. But the other three are, in my opinion, the pillars of how to form a community.
Okay, I totally agree with you on that. The next one is, what are community ambassadors and how shall someone be one of them?
So community ambassadors are those that represent communities locally. So I'm personally not a community ambassador. So I cannot comment on the roles and responsibilities, but I know a lot of them who are community ambassadors. They represent the specific technology that they are working on locally, or even in case of non-profit organization ambassador, which like CNCF, CDF ambassador, they are representing the products, software that are shipped by that particular organization, and they basically evangelize it. They promote the knowledge around the product in their respective local communities and attend conferences, that sort of a thing. So that is what a community ambassador looks like.
Okay. And the other one is like, are there any qualities that a community contributor needs to have? Any top three?
So top three would firstly be willingness and a hunger to learn. That is the most important, because nobody knows everything in a community, and it is very difficult for one person to be knowing everything. So a hunger to learn, a curiosity to learn should be the first and topmost one, followed by communication skills that are even average communication skills are pretty good, but you need to master your communication skills, given that you're not going to be uh, uh, talking to just one person or like two or three people. When you are working in a community, there are different folks who you are going to be talking to. So mastering communication is something that is another top skill that I would rate. The third one would be um, the ability to put in hard work, because a lot of people, when I speak to them about joining an open source project, the first thing they say is, "Oh my God, I have to work outside my daily job," and it's, how do you manage it? It's impossible. So it's all about taking our time and putting in the work. It is not about whether I have more capabilities than you, or whether I am better at communication than you. It's all about putting in that hard work and taking out the time to contribute, because when you actually want to do it, you will find a way irrespective of that. So a willingness to contribute and put in the hard work. So those are my top three.
Okay. And the last one is like, if someone wants to be the part of the community. So the first question it was again, so if they want to apply for it, is there a portal or something where they can do that?
No, so each community has a different way of engagement. Personally, I can speak only for the communities that I am part of, but I've noticed the similarities in other communities. So I'll generalize the answer by saying that you need to visit their repositories on GitHub and explore. The first step would be that. The second, actually scratch that. The first step should be actually visiting their website and seeing how they accept contributors. That should be the first step. The second step is looking at their contributor guide. So the contributor guide typically is there on their website. So the contributor guides guide you on what are the prerequisites that the community is looking at from your side, to in terms of skills, or in terms of agreements that you need to sign. So there are agreements, contributor level agreements that you need to sign before you start contributing. So that all of those will be listed in the contribution guide. So that is something that's there on the website for most communities that I'm part of. So that's the very first step. Then you go ahead, create an account on GitHub. If you don't have one, check out their various check out the various repositories that that particular community has. So in my case, it was just Kubernetes, obviously, but then I found out from contributing on Kubernetes that there are other projects that I'm interested in, like Litmus Chaos, which is a chaos, chaos engineering tool that is open source. So that is one thing. Then OpenEBS is their sister tool. Then we also have Hoteliers, which is another thing that is related to microservices management. It is something that you develop an interest in once you take that first step. So the very first step would be to understand if you are, if there's a particular open source tool you want to contribute to, visit its website, check out the contribution guide. That should give you most of the information.
Okay, thank you, Divya. Yeah. So what a way to kickstart your morning with, right? Basically, how to be an open source contributor and how to get along in communities. So moving ahead, now we have panel discussion regarding DevOps. Vinay will be taking it. So Vinay, over to you.
Hey, thanks, Avish. So first of all, good afternoon to all. So who are viewing right now, so welcome to OSCONF Jaipur, the pink city, basically we call it, right?
Yeah.
Good to catch up with all these beautiful folks right now. And yeah, so I also belong to Rajasthan, so I'm very excited to be part of this event right now. Okay, hi. So myself, Vinay. So I have around a 13 plus year of industry experience. Yeah, so I started my career with, so little background with VMware. I worked for a good time there. I've learned lots of things from there. Then I moved to Pune for a short time. Then I switched to Oracle, and then now I'm working with the Dell. So I'm currently working as a DevOps engineer. And so the topic today we are going to talk about is DevOps, right? The reason to come up with this topic, so this year we are hit by a very bad pandemic, right? COVID-19. And so during this time, we have seen lots of up and down during the software industry. Many of us got impacted, and there are lots of college graduates who are coming out of college and a little bit struggle for the job. And so I have seen around lots of queries around on my like LinkedIn chat or other channels. There people are asking how they can ramp up in DevOps. Okay, even Ajit is there today with me and Apurva, and we have a beautiful team from Jaipur also. So what we thought of, let's share our experience, industry experience on DevOps. Okay, how we have ramp up, or how we have skilled ourselves, so that we can help anyone whom he or she can refer this. Okay, so we have come up with few set of questions which we picked up from the users over our channel. Okay, and so we thought of, let's discuss this, and feel free to drop questions over the YouTube live chat. If time permits, definitely we'll pick some from there. Okay, and I want to be that interactive, right? So that this is what this panel discussion all about. Okay, so with me, Ajit, I know very much everyone aware about Ajit. He's the one who started this OSCONF plus this Collabnix beautiful channel. And he also has, I think, 13 plus industry year experience. And he has a vast knowledge on DevOps, okay, to other areas about lots of tools and all about DevOps. And other than that, we have Apurva. He also has an in-depth knowledge on DevOps. He's starting from his career, is working on that field. Okay, so welcome to panel discussion, Ajit and Apurva. Okay, so I'll just like what we are going to do, Ajit and Apurva. I'll ask a few of the set of questions with you folks. Feel free to answer with your experience and what you make out, like how it is going to help the audience, everyone who may view this like video later on, and how they can leverage our community, basically Slack community, or say we have a Collabnix space. So how we can help them, or how they can come and contribute to us so that they can also learn in their free time. So very first thing, Ajit, let me ask you very basic question, right? So what everyone's want to know, maybe this term is very not that new. So what exactly that DevOps engineer do? Okay, so this is very basic question when you face when someone asks you, right, what exactly you do, or what is the DevOps engineer profile, basically, right? And as far as I know, it's a very vast. Okay, so there is no single line we can answer it. But I would like to hear from you, Ajit. So let me know what your view on that.
Yeah, thanks, Vinay. Can you hear me?
Yes, Ajit, we can very well hear you.
Okay. So thanks, Vinay, for having me for this panel discussion. Definitely, this is one of the discussion I was looking out for, because I too received a lot of queries. And, I think this will be a platform which can help us based on what we have learned in the past. So thanks for having me here. Okay, so to answer your first question, right? What does DevOps engineers do? So the first thing we need to really understand is when we talk about DevOps, it is not just a developer doing the operation work or operation doing the developer's work, right? It is more of the collaboration. It is more of a culture, right? And the reason why we are bringing that kind of a culture is what we are targeting today is more of how we can go ahead with a faster time to market, right? And when we say faster time to market, we are considering the security, we are considering the quality of the product. So as a DevOps engineer, since it is more of a collaboration, it is more of a culture, they have day-to-day activities, and these day-to-day activities could be anything from a project management, from designing the IT infrastructure, or it could be a performance testing, or it could be an optimizing the release cycle. So I do see that if you look at the developers, right, usually they spend more and more time on building their code and then ensuring that it get committed to GitHub or any of the version control system. And then the operations guys, what they do is they take that particular code and try to go ahead and deploy it. Now, before DevOps, it was very difficult, right? Because teams were working in silos. But now, since with the collaboration, the responsibility has increased in such a way that now you are thinking of a bigger picture. There is no cookbook, or there is no a kind of a technical guide for a DevOps engineer. All he has to do is he has to collaborate with all the stakeholders. Say, if you are in a kind of a business where you are delivering a kind of telecommunication business, right? Now, with a telecommunication business, if you are a developer or a C developer or a Java developer, you have to go ahead and build the code. But at the same time, you need to know the bigger picture. When it goes to the customer, you have to get the feedback out of the customer. You have to do the performance testing. You have to do the monitoring. The moment you see a DevOps or tech stack of any company, and what are the tools and techniques you see on the tech stack, you have to take care of all of these things end to end. If you will look at the DevOps engineer side, sometimes when you work as a DevOps engineer, then you become a DevOps manager. So which means that a DevOps engineer has to also consider it as a management. He has to go ahead and take a lead in managing when, where, how, who is taking care of this, how it is being delivered to the customer, whether customer has tested this particular product or not. He should be aware of all those deadlines. He should be in regular contact with the customer. Other than that, if you talk about the developers, when developers need some kind of an IT infrastructure, you have to ensure that you have to give that infrastructure to them. If an automation test engineer is taking more and more time in running his test script, you have to bring more modern DevOps tools. You have to recommend that. So as a DevOps engineer, you need to identify how you can improve, okay, improve this to encourage the collaboration in between them. Okay. And since you are responsible for end-to-end solution, I think automation, optimizing the release cycle,
one of the new things which is coming up is the DevSecOps, because as a DevOps, you always look out for faster time to market, but you leave few of the security stuffs behind, right? So we have a DevSecOps, which has been introduced, which means DevOps plus security. So as a DevOps engineer, you have to take care of the DevSecOps roles too. So, and the major part of tech stack goes to monitoring and logging. I think you should be aware of such kind of a tools like Prometheus and Grafana, and you need to know lot number of tools. Look at the resume of DevOps, right? You see like 3 to 4 pages filled up with number of tools, and that is required. You need to know each and every tools which falls under the tech stack. So I think DevOps, it has a huge responsibility in building the business, in basically for the faster time to market, in building the skills, to go ahead and run those businesses.
Yeah, I think, yeah, that's right on the lines. What you said is perfectly correct. This is, yeah, what I said is, this is like it's a big like a big ocean, like what you said, DevOps, right? It's not a single job. When you said about developer, developer is one who develops the code, right? So he can be good in one area, say Java or whatever he prefer. And when you talk about testing, QA, he can do. But DevOps is like a collaboration of both. Am I right? So he has to be good in all. Okay. And practically it's not true, but yeah, he has to be aware of these things. He has to build the gap, okay, between the developer and operation, basically, when you call up. So he has to be aware of the latest stack, what is going in the industry, and what he has to be, so that he can help bridge the gap between the two basically teams. Okay. So my next question is around so why is DevOps so important in present times? Okay. So let me answer that. Maybe I'll just give a brief. So it's very so a few years back, maybe in 2013-14, I was working in one of the company, right? And all of a sudden, this DevOps field emerged like anything, and everyone was talking about this DevOps. Okay, and before that it was not. Before that it was like a model SDLC. Okay, so there is a developer, there is a QA, and once developer writes a code, they check in, they create a build, and then it's a QA team. Now they're going to test it, and then they're going to file a bug. So this is how the process goes on, right? And then the industry have seen lots of changes. You might have, like in 2013, right? The Docker came in the picture. Then lots of other tools came, and as that is the time that DevOps feel also this term has evolved. Okay, so what basically, why it's so important? So it is important in the sense because whatever DevOps engineer do, right, he or she build a quality deliverable. Okay, that is the more important. How he builds that. So as I said, previous to DevOps, there is a QA plus there is a dev, right? There is a cycle on that. But what DevOps engineer do that, they have this DevOps technology introduced lots of tools. Basically, we call as there is a concept of we call as CI/CD, like continuous integration, continuous delivery or deployment. That is very most important thing, and that helps the process to speed up. And that's really a one major, what we call as it's a fully automated. We can do that. So as soon as the DevOps engineer design that pipeline, that is the responsibility of DevOps engineer. Okay, so he or she, like the engineer person, has to be knowledge or has to be good in that to design the pipeline. There are lots of tools. We can name one: Jenkins, Hudson. These are that most famous. TeamCity. There are lots of tools which we use right now. Okay, so he or she, like DevOps engineer, design that pipeline. What it do is that in that they take the code as soon as the developer check in, and then it will kick off the build. And then what it do is that it will complete the cycle within some time, and if there is any bug, it will report it back. So what it has done, it has improved the quality, right? It is not like the developer has checked in and then the QA will take it, build from there, and will do the testing and come back, right? It will immediately do the within some time, and then there is a continuous integration, it call as. So that is why these role, basically DevOps engineer role, right, that possesses a very important role. Now the second part, you might have seen now the everything that like most of the industry has moved from on to off-prem, basically when you call as towards the cloud. and there what the there is the role of DevOps engineer comes also play, right? So he or she like has to be aware of this cloud technology so that it can be taken care of the infrastructure part also. Okay, so that is also a very important part in the DevOps world. Okay, so and then when you talk about cloud, right, then there comes we are now today interacting with lots of Kubernetes, right? That is Docker management and Docker. These all tools or these all terms comes in the picture in the DevOps, right? So that is why this DevOps field makes so important right now. When you talk about any good organization or any organization which is, they have highly in demand of DevOps field right now. And so when you talk about any good platform like media platform, Netflix, any Amazon or all these things, they all are on right now cloud, and for that they have a backend DevOps team, right? So that is the reason this DevOps field is so demand, and that is the highly like I would say like highly skilled right now. You have to be like, because you have to be smart in each and every corner of that. Okay, so that is the reason. Basically, if I see the industry pattern or if I fed the data from I've seen from internet, so what it says that what DevOps engineer do or DevOps quality this field, it highly it's it makes the life cycle easy for the product delivery. That's right. And then it is like increase the collaboration between developer and a QA, I will say operation, basically, because developer don't have to worry about like deploying that, and QA doesn't, our operation team has done, don't worry about that, right? That is taken care by the DevOps person who is going to design that for them a pipeline or say a proper infrastructure. Okay, so that is in nutshell, I would say that is why this DevOps field is so important right now. I hope Ajit, do you want to add anything, or Apurva?
Yeah, true, Vinay and Ajit. I would like to add some more point. Like I could say, there are some myth like in the DevOps field that if I want to go for the DevOps jobs, or if I want to deep dive, or if I want to get the job for the DevOps, I know bunch of tools. It is not the it is not the correct way to understand the DevOps. Like I have hundreds of tools of knowledge, but I am not using those tools. There is of no use that I know the hundreds of tools and I am not using that things. So here, like if I talk about like DevOps more the things, so once the developer done with the code, the next thing, like when we are running the codes into the production, that will be totally take care of the DevOps, or I could say the SREs. So what I could say, like DevOps is more likely the bridging the gap between ops and dev, and how we can accelerate this process. Like if you already talked about like CI/CD, then deployment and staging, then prod, as Ajit said, like monitoring stuffs and all those things. So these are like more important things. Whether you are using Jenkins, or whether you are using like Travis CI for CI, whether you are using like stuff like Kubernetes for the deployment, as application deployment, or you are using like EC2 instances, that doesn't matter at all for the DevOps guys. What DevOps will do, how we can accelerate this process, and how it is more compatible, and how we can up and running the production server, like we can give the more uptime. So if I talk more about like uptime in the sense like in a uptime like, so it will be like if I talk about like Docker or Kubernetes, it is like more modular, or it is like a platformless type of stuff, where I can spin up this application very easily on any cloud. It's not like if I talk about like AWS, then I am running the Lambdas. Same kind of stuff, if I go to the GCP, I will run the application on Cloud Run. It is not the case. If I have built any application for with the image, that image I can run on any platform. Like if I can run it on DC data centers on standalone server, I can run those applications on cloud too, or any cloud I can run those applications. These are like beauty of the DevOps, where we can migration of the application from monolithic to microservice. Once again, I will go back to the monolithic type of services. If I do not really want to migrate my monolithic application to the containerized one, and I do not have like problem with the current scenario, then definitely nobody has to try to do this application into the containerized one. So if I talk about like once application is moved to the staging to the production, So there are like I am from the there with some of the SRE aspects. Like I cannot say I have implemented all the aspects of the SRE, but what site reliability does, the site reliability terms are in like first of all like introduced into the Google. So what site reliability engineers do, it will start to start more focusing on SLI, SLO, and SLAs. So if I talk about like SLOs, so SLOs work with your error budget. So if I am saying that my application uptime is 99.9% up, that means like 99.9 by month. If I'm calculating, then I have like 0.1% downtime per month in my hand. So if I have calculated 0.001 into 30 days by month into 24 hours by the day into 60 minutes, so it comes to nearly around 43.2 minutes per month. So you can consider like I have like 40 to 45 minutes of downtime per month in my hand, and I will make sure that my production application is up and running in the less than this time. So here how you can calculate the error budget kind of stuff along with the SLOs.
Yeah, thanks, Apurva. I think, yeah, so that is what all about, like, so there are lots of terms here, there are lots of jargons which we are using right now. Maybe those who are new to that, they may be thinking like, what all this? So the next question comes around here is that, so how to possess how to become a DevOps engineer, or what all skills we need to have to become a DevOps engineer, or when we are looking for a job change as a experience also, or as a fresher, whatever, say, when you anyone who comes out as a graduate, what all things I need to learn. Okay, so there are lots of these questions which comes on my page, or maybe I've seen Ajit, or lots of things we are answering on our channel also. So I'll take this question as I'll try to answer from my end what I have done from last few years, or say recently also. I'm trying to leverage whatever I can learn. So this is like a continuous learning, first of all. Okay, I will bet you on that no one in industry who call himself or herself as like a pro in a DevOps engineer, okay, who has full hands-on on each and every part. Okay, so now to narrate this, what exactly we possess as a DevOps engineer, I'll break down in like 4 to 5 quadrants what I try to learn. Okay, so very first thing, when you talk about DevOps engineer, it's like a developer plus operation role, right? So you need to start with like from the developer point. As soon as there is a developer who writes the code. Okay, so you think about there is a product or there is an application. Okay, there is a dev team. They are going to write a code now. Once they have written a code, so very first thing DevOps person has to do is that they will have some central repo. Okay, so when you talk about, I'll give you few central repo, like Git is very famous for that, right? So very first thing, they will check in a code from there. Now the DevOps engineer role is to how to design how to design from there, basically, right? So there comes the picture here. Like DevOps engineer has to be aware of that Git. Very first thing I would say, like basic knowledge has to be around from any source control tool, basically we call it, right? So that is they have to be aware. They have to take a basic knowledge of that. Okay, now after that, when you talk about, when I said that this person has to be aware of that, basically continuous integration, continuous delivery or deployment model. Okay, so that is the major role, I would say that. So that is the good skill the DevOps engineer should have, basically, I would say, right? Without that, it sounds as incomplete, because that is the first stage which you're building a gap between a developer and a operation team. So I would say second, go for that, basically get knowledge around these tools, and these are not so tedious or something. There are lots of good documents or lots of tutorials, you'll find it out, which I also learned from YouTube, or we have lots of, even Ajit has written few beautiful blogs where I have used those blogs, how to create a Jenkins pipeline or say Jenkins server using a Docker, right? It barely take less than 10 minutes and your Jenkins is up and running. And I would say that is the best practice. You can do it. Just deploy as a container as a Jenkins server, and you will be having your server and a client and play around it. Okay. And if you want, we have a reference or that page. So you go and search how to create a Jenkins as a container and do play around. And that is the first thing which I have done, because in industry, I would say as a personal experience, you don't get everything hands-on, okay? Because it's a team effort, right? So you'll be, maybe I'd say like I'll be working on cloud platform, so I don't have access to my maybe say Jenkins, so that I have not done that. But when you want to move ahead in your career, right, you want to say anything, but they expect you to be pro in everything. At least you should know, okay? So when you want to build a career from the scratch, or say in the pro as experience, what I'm saying is that you need to learn all these things, okay? So even I have deployed my as a container, and then I have created few pipelines, okay? And as I'm repeating again, there are lots of good documents, so do use this platform like say YouTube. Then we have lots of courses on other platform. Do search and learn about this tool, basically CI/CD, and pick anyone. Say most famous right now is Jenkins, and then we have Bamboo now coming, TeamCity. Okay, so that is the first. And then now the second block, which I would say that now most of the industry are moving from like on-prem, right? When you say on-prem, like the infrastructure which resides in your in your office, basically. And so it is like, I would say decade back, that industry pattern was like you have a private lab and you have a server and everything is deployed there. Okay. So when 2000, around 2006, when I started my career, VMware was like, it's a hot cake, right? So there, because you have virtualization everywhere, and then you can, using single server, you can have n number of VMs, right? And then few years back, I would say down the line again, a decade back, then cloud terminology comes in the picture. Now, when you talk about cloud, that is the second quadrant, right? So now industry is taking care of like cloud. So the person who wants to build your career in that, they have to be aware of one of the cloud technology. Pick any cloud. There is nowhere, because all this stack are same. When you talk about, there are 3 layer: IaaS, PaaS, and SaaS. Okay, so these 3 layer defines your whole architecture. When you are aware of these 3 layers, doesn't matter whether you work on GCP, AWS, Azure, they all differ in little bit on their services. But if you know any one of that, I'll bet you can make out the other cloud platform very easily. So pick any one cloud platform, try to learn. There are n number of sources now. In 2020, I have seen like lots of, there are lots of free channels, or lots of there are bloggers who writes, and you can learn from there. And there are lots of free courses. So second thing, what you have to take care by that, learn any cloud infrastructure, cloud platform. Okay, that is also a must when you want to build your career in DevOps. Okay, and now, so when you talk about cloud, okay, so that is one. Now, so when you talk about cloud, in that, why industry is moving to the cloud? Because they are moving from monolithic to microservice. I'll just give what is monolithic is like each and every component in single. And when you talk about microservice, they are breaking down each and every component in a separate node. And when you talk about node, there comes the picture of Docker and Kubernetes. I don't want to take much time. So what I mean to say is that when you talk about these, there's third quadrant, you need to be aware of these technologies. Docker, Kubernetes is the one who is the container management. So do tick mark these 3, do tick mark these 2 also with that. So that you'll be having, like, when you say that, okay, yeah, now I have learned something which I can say that I have leveraged I can do a bit on DevOps. Now there are lots of tools. See, DevOps, there are 100 of tools and one cannot be pro in that. Okay, so pick what you feel you can do that. Like when you talk about cloud, there is an infrastructure as a code, IAC, right? So there are lots of tools that AWS has their own Cloud Foundry. Then there is a Terraform. So when you have time, learn these tools also. Okay, but like you have to make sure, like you have to take it to day by day. Okay, but before that you need to learn about cloud. Then you can go ahead about the next step, go about like infrastructure as a code. Okay, now the third important thing which I feel is the most important, you need to be aware of about the scripting. And that is the most important when you talk about this, right? Like, so pick any one of the scripting. And I'm not saying someone has to be pro as developer, but he or she has to able to recognize what scripts are doing, or he can write, because that is the part when you're writing your pipelines, right? So that is even I have learned over the years. And so pick like Python is very one famous scripting language. Then we have Bash. there are many. Go is coming up in the coming time. Golang. So you have to be so without fail you have to be knowledge about either Python or any scripting language. Without that, it's very tough to move ahead in career. Even after so much of experience, they ask you all these questions in your career while interviewing you. Okay, so that is one. That is the third quadrant. I'd say that pick any one language and then try to do at least basic of that, not to the core. I mean, not to the extreme, but at least core you have to be aware of that. And then last, when you talk about deployment and delivery, there are lots of tools which comes in the picture, which we have already talked about. Like, so there is continuous monitoring, then there are lots of tools there, right? So it's good to have those tools in your knowledge, but if you're not, then it's okay, because one cannot be expert in all. So there are lots of tools when you talk about Prometheus, Grafana, Nagios, and those are part of continuous delivery. I mean, it's continuous monitoring and logging, right? So this is all about like one has to be, these all 4 or 5 corners you have to tick mark, and then you can proceed in your DevOps career. Okay, so I think to break it down, you have to be good in scripting, you have to take a good knowledge about cloud, then definitely about continuous integration delivery, and then play around with lots of tools around it, say Docker, Kubernetes, then lots of other tools. And then you can say that, okay, now I'm ready, and you can proceed with your DevOps career. Okay. So that is what my take is. That is what I'm doing day to day. And even I would say take one day as a learning. And so I'm really thankful to Ajit and all this community, whatever he has done. He has written lots of good blogs, and he has lots of good channels right now, like Docker Lab, Cube Labs, where if I go and it's not like everyone learns like by heart it, right? So you have to be refer every time, right? So there are lots of good memes or got good posts there, which I do play around and refresh my knowledge. So anyone want to refer can go and refer there. Okay, that is my take. I'll take maybe a couple of minutes from Ajit. Do you think, does it cover all, or is there anything you want to add?
Yeah, so Vinay, I think you have covered most of the stuff. So based on the experience, right, what I would like to say, so there are now 3 types of people, who have reached out to me saying like, okay, if you are a very fresher and if you want to really go ahead and start with DevOps, I would say the first thing which you should go ahead and refer is the GitHub. Try to look out for your favorite programming language. If you are very good, or if you have an interest in C or Java or Python, just pick up the programming language. Based on that, you build some kind of a product, and don't build it as a single army person, right? So you have to do the collaboration, you have to collaborate with others, so that you grow the sense of collaboration right from an engineering background, right? So as an engineer, I would say, because I do see one question say like, as a student or fresher, how do you recommend to start with the DevOps? And one of the thing which I can recommend is the GitHub. Get into the collaboration with other folks. Try to be in a Slack or Discord. These are the channels which will help you out. Rather than being in WhatsApp, I would suggest the Slack, because with Slack, there is a lot of integration which come into the picture. You can integrate GitHub, you can integrate every leading forum, even you can integrate the tweets, because you need to know what is happening across the globe, right? If you go ahead and follow the tweets from say any of the product, you will get to know what are the new announcement which is coming up. And as Vinay said, right, it is a continuous learning for sure. You have to go ahead, you have to learn about the new tools. Now, one of the myth which Apurva was talking about was it is not necessarily that you learn 100 of those tools. Yes, it is good to say that you learn them, but you have to analyze them in such a way that when tomorrow, when you join any company, or you are working in any of, you have say as a Linux administrator, you are working in any company for almost 10 years, and now you want to jump into the DevOps. Now you should have a skill to go ahead and recommend those tools to top management. And that is the where you can switch from your other jobs, like as a developers or as a tester, into the DevOps. One of the thing in DevOps is 100 of tools, but you need to pick up the right one. And that requires an analysis of all those tools. Say if I am, so while working in Dell, we used to use Nagios as a tool, right? Now, Nagios tool works very great when you have a legacy application. But what about when you are in a container environment? You can't stick to Nagios for a long time. You have to have a microservices architecture, and that is where Prometheus, Grafana, InfluxDB come into the picture. You have to pick up the right tool in a form of a microservices for your DevOps engineering, and that is more important rather than learning 100 of them. So I think that is something which I wanted to add.
Yeah, great. I think, yeah. So I hope this, whatever we answered, like that will create lots of air around that, what the DevOps engineer has to do that, like what skills. So they can focus on this and try to build around this area. Okay. So I have one question around like, Ajit, maybe let's see.
Sorry to interrupt, Vinay. Like I would like to add one basic things like that you or Ajit missed, like choosing of the platform. Like if you want to go with the Linux or the Windows based platform, that is the first basic things that you should know. Like if I want to go with the Windows based platform, or if I want to go with the Linux based platform, because again, if you talk about like Linux or Windows, these are two different entities. Like where if I'm using Linux, it's open source, and if I'm using like Windows, it's like legacy services. So again, if I'm going through like Linux, then I should know the shell scripting kind of stuffs, and if I'm using like Windows, I should know the PowerShell. So before moving ahead and jumping into the DevOps, you should know at least basics about and the command line and so on Windows, either Windows or either on Linux. That is the basic foundation of the DevOps, I could say, because at the end of the day, if you are building any application, you are running on any of this platform. It may be Mac, it may be Windows, or it may be Linux.
Yeah, that's true. Thanks for adding it, Apurva. So one question, Ajit, how can you differentiate Agile and DevOps, or I'll say SDLC? So do you want to take this?
Yeah, sure. Okay, so to learn DevOps, first you have to learn SDLC for sure. Because whatever you learn during the engineering, is software development lifecycle. You learn about the waterfall and the agile model, and now we are talking about DevOps. Okay, so let me go back to the waterfall model and then try to explain, because this is a really important question. If you look at waterfall model, it is more like a kind of a cascading kind of mode of working, right? You have a developers, you have a testers, and then there are customers, right? So when a developers write a code, that has to be tested by the tester, and then it goes to the staging and then to the production, and you have a user acceptance testing in between. Now, if you look at the waterfall model, things, it takes around 6 to 12 months of time based on what kind of a product you are building. But one of the problem with waterfall model was it was taking a long time. So you spend 6 months and then the product reach out to the customer, and the customer comes back saying like, okay, you have a lot of things which are missing out. So that was consuming a lot of time, and that worked for sometimes because waterfall model has been there for around more than 40 to 50 years. Then with that, to expedite this process, we have an agile method which came into being, right? Where we call it as after every 2 weeks, you used to have some kind of a meeting where you go ahead and update to the project management what is the progress of the project. Now, this was a bit of improvement because now things are going good, because earlier we were talking about 6 months, now it is 2 weeks. There is a couple of meetings every week which happens in between, or maybe updates like every day. But the problem was, when you accelerate these kind of a stuff, sometimes when some assignment or some of the updates has to be given by the developer, usually few of the things doesn't finish in a day or a week, right? It usually take time. And one of the response from the developer was, okay, I will inform you when it is done, because when it is done, it is done. And that is the reason what happened is these sprints were were not applicable in such a way that you have to think about the security point, you have to think about the quality of the product. It was just like you are chasing someone for a product, but still there was a kind of a silo in between developers and operations. So when you talk about DevOps, right, DevOps is from a day one, you are basically a developer and the operations, they are working very closely to each other, which means that you don't have to give them the updates. It is more like a DevOps team where you are taking a charge or the responsibility of what happened today and what is going to happen tomorrow. You don't need to have a frequent meeting for that because you are always updated. And this is more like how you basically go ahead and interact it into day-to-day basis. Thanks to the tools like GitHub, where you get a notification out of it. Thanks to the tools like Prometheus, where you get the operation team gets all of the notification, what is happening. And it has been, we, as Vinay said, right, we have a continuous integration, continuous deployment, continuous development activities, which goes in parallel, right? So DevOps brings that notion of where you work very closely. Just think of it like the whole company is sitting in a small cube and they are updating each other every minute or every hour. So you don't have to go to the meeting room to go ahead and talk about what is an update, right? So DevOps is that culture. And usually the thing is, the information or data about that particular update is automatically coming to you. If we are working today as a Slack and conducting a conference, think of it as like a DevOps model where you are getting information each and every time. I don't have to call you and get an updates, right? So I think that is one of the difference which DevOps brings to the table. And it is all about how you accelerate the development cycle, how you accelerate the deployment cycle, as well as using tools like Jenkins and Bamboo, right? So those tools basically accelerate your continuous integration cycle. Yeah.
Yeah. Yeah, that's very much what your answer is correct, Ajit. So I'll take one more question here, and that is very famous question. I will say, like, even I've got lots of queries around it. Like, does DevOps engineer need to have a certification? Like yeah, so I think Apurva laugh, even Ajit and me. Actually, it's like a debatable. With all due respect, it's my personal view. Whatever I'm going to say here, there is no personal. Like, this is what I believe, and that is what my learning is. That so. Even I've got lots of careers of which certification I'll do to become to continue in this career, or say is this course certification. So what my take is that I don't believe like certification is a tag which makes you are like a good DevOps engineer. So what I feel, the experience and hands-on learning will do more for you to continue in your career, or to learn more in your whatever the day-to-day job. So whatever you do in your hands-on, or say whatever you can learn from wherever is available resources, do learn that. But if you are really passionate, say you are really passionate about that terminology or that technology, say about Kubernetes, right? You want to build career in that, and you want to be learn in depth. Then I would say go for that certification, CK or CKD, whatever you feel comfortable, right? And so that makes sense. But to make like your resume fancy, or to make to show like I am 10 times certified, I don't know, like that personally I believe that's not required, because that required lots of money, and not everyone is so much fascinated about like you have 10 certification. But when it comes to implementation, I don't know like how much they can do that. Okay, so to answer that, if you are really passionate about cloud platform and you want to do like, okay fine, I want to go in depth, go for it. Okay, to go for any one certification which you feel, but don't go for like to show someone, okay, I'm certified. That is what my take. Okay, even if I see Ajit, right, Ajit is being from long and he's running a lot. I don't know like how much certification Ajit has right now. If I can see that Ajit.
So the last certification I had was for VMware, and after that I didn't have.
So Ajit, I think that was 10 years back, right? Even I have done that, and that was like 2011. I did in 2010. Okay, so that was in 10 years back. That was also like, yeah, because we were in VMware and we want to know about that. Your Ajit was that, so we learned that. After that, whatever I am learning, that is all hands-on learning. even if I take Apurva, right? Apurva has, I think, couple of certification from CCAT, right? Apurva, because he's very passionate about Kubernetes. I can see his career build around that area, but he has not done other certification, if I'm not wrong. Apurva, you want to answer that?
Yeah, true that. Yeah, whenever I'm appearing for any interviews, first of all, interview will ask me like, why do you have like lots of certification in your career or something like that. So it is not the case like I want to give this exam. This is only the things like I want to check my abilities, what I have done, and how much I have experience in this case. So the basic things only I need to check my abilities. That's it. Nothing apart from else. Like I have to do this certification and I will get the job. If I'm appearing for any interview, they didn't ask me whether you are Kubernetes certified or not. That doesn't matter at all. If I look back to my previous certifications, like I have like RHC and RHCSA. That was like again the same things what I had done. Like the only thing is whether I can crack the exam or not, if I am having that much of knowledge or not.
Yeah, so I think the single line what you can, don't run around certification. If you are really willing, you want to really want to build career, then go for certification, because it requires like you need to spend some money and you need to have good knowledge. Don't go for dumps. Okay,
Yeah.
it make you dumb, because that means the dumps means. Okay.
Yeah, true the things. So if I ask you like, if you ask me like AWS certification, so people will go and take the dumps and write the exams.
Yeah.
So if I'm appearing for any interview, and suppose I have cracked the interview, and before cracking the interview, somebody asks me like, why don't you have like AWS or GCP certification? If you are working since more than 4 years or 5 years, so I will simply say like, I have the experience, I have the knowledge, I have hands-on experience. And if you want to do me the certification, definitely I will do once I crack the interview. And definitely people will agree on this. If I am able to crack the interview, that means I have hands-on and the knowledge on the particular technology.
Yeah, right. So even it's same with me, what I said, right? So you can't have certification because in the cloud right now, there are multiple vendors. You name one, they all have cloud. You can't be certified in all. So better to learn, do hands-on. That's all I would say, right? So to answer that, yeah, this is what our experience says. But with all due respect, like you can go for certification, there is no harm. But it's your, like, you have to use your mind. That's all. Whatever you feel good, go for it.
But before appearing for any certification, I will suggest you that go deep into the technology, go for the hands-on, do explore the things, and then appear for the certification. Don't just go blindly and appear for the exams, because whenever I'm just so a lot of people are asking me like, I want to crack the CK or CKID just for the namesake, and I want to get the job into the Kubernetes or microservices field. That is not the correct way, because a lot of people appeared for the CK 2 or 3 times and they got failed. The reasoning is being that they are not much knowledge or hands-on around it, and they didn't explore those things.
Yeah, so I think that's all we want to say around this question around. I think we are on time right now. I can see like we have covered all the required areas which we want to cover about DevOps. And so if anyone has like any other question right now, they can drop on Slack. We have Collabnix Slack, or you can reach out Ajit, me, Apurva personally. Also, we have our LinkedIn or anywhere, any social means, and feel free to drop. Okay. That is what we want to cover for today. And really thanks Apurva, Ajit for the panel, and thanks for the Jaipur team to having us. So I think we are done. Okay, so over to you team right now.
Thank you, Vinay, Ajit, and Apurva for this wonderful panel discussion. It was really informative. So moving ahead with our next speaker, Mr. Arvind. So Arvind is passionate about evangelizing technology, meeting developers, and helping in solving their problems. He is a backend developer and has 8 years of development experience. Currently, he works at Elastic as developer advocate and looks after the developer relation function of India, Southeast Asia. So with that, a warm welcome to Arvind. Over to you, Arvind.
Thank you, Harshita, and entire Collabnix community for organizing OSCONF. I've been trying to, submit or speak at OSCON for quite some time, and I was not able to do that. And this time I think somehow like saw that on paper call, and then I submitted a talk and gladly accepted. I'm really glad to have here, and thanks entire community, Ajit, and all the people who are coordinating. And I would really be excited to speak at this one. So I'll share my screen to start with, and then we can get going. Okay. So can you see my screen already? Harshita?
Yes, we can see.
Yeah, great. So, so specifically, this talk is about deploying Elastic Stack on Kubernetes. How do we do it? What are the things that we have? I believe you might be talking about a lot of things like, containers, Kubernetes, like orchestration or various other things. I've seen Argo CD, specific information on that, and then like I think some other talks on application development as well. So what I'm going to talk about is like I'll skip if the time permits, we will cover most of it, but otherwise I'll skip general knowledge and then like move over to whatever I want to cover. But to get started, today I'm using the Google Kubernetes engine because cloud is something that now everyone is using and for everyday use cases as well. So I'm just gonna demonstrate everything on cloud itself. So so in the interest of time, what I'm gonna do is like spin up a cluster, go back to the session and do some slides, and then we'll come back and do the demo on this thing. By this time, the cluster would be ready. So I'm gonna put my name. Okay, and because I think we are in India, and then I could choose AP South A. Probably this is Mumbai, I believe. And then we could use this one. So I'm just gonna create this cluster. I'm not gonna choose anything else, and then just click on create. This is GKE, as you know, Google Kubernetes Engine, which is a flavor of Kubernetes that is an open source project, right? So we'll get back to it. Let it run, and then we'll come back and we'll look into all of this. Now let me present. Great. So before, I think Harshita has given a great information about myself, but I'm Arvind and I work as a developer advocate. And then I used to run, DigitalOcean cloud community in Bangalore previously. And then that's how I started doing Meetup. I know Docker Captain Ajit. I know him, I met him quite a bit times, but over a period of time, Ajit has done great work into Docker world, and also like with other community members like Nipindra, Karan, and Vivek. So a lot of people. I think it's really glad to see everyone in the community, do more and more work around it. So that's about how I started in the community, and I blog at the specific place, and you can also always DM me at the Twitter. Now the key takeaways of this session. So what you would get if you would completely listen to this session. So I'll not bore you around. I'll try to go fast. And if you have any questions, stop me in between. Ask questions. I'm definitely looking at the chat window as we speak. So please ask questions, and then like we can go to that. So the key takeaways is running the Elastic Stack on Kubernetes. So Elastic Stack is an open source stack where there are multiple components, and each component does specific things. But the idea here is to how do you run this open source component on the stateful system on a Kubernetes kind of orchestration platform. Now, what is Elastic Stack? As you might be knowing, Elasticsearch is a search engine. It's a distributed NoSQL REST-based storage engine. And then you have Logstash and Beats, which are ingestion modules, which help you to push data into Elasticsearch. It is also popularly, let me cover Kibana. So Kibana is a visualizer which sits on top of Elasticsearch. So people popularly call it as ELK, Elasticsearch, Logstash, and Kibana. Logstash is like your ETL, like your extract, transform, and load. If you have ever seen or heard about these tools, like maybe it's old now in the cloud era, but Informatica or Cognos, Ab Initio, these are the tools that people used to use in the BFSI world everywhere to shuffle data, to marshal data from one data warehousing place to another database, and to transform that in between. So Logstash is one such tool. You can also compare it with something like Talent. Beats is more of like a data shipper tool. It ships data out of your infrastructure and places to Elasticsearch, and thereby you can visualize it in Kibana. So another parallel that you could use is like you could also use Grafana with Elasticsearch. That is one another popular thing that people use. Grafana is another visualization tool which helps you to do that. But stack is this one. Whenever I say stack, this is the stack that I'm talking about. Over the period of time, Logstash is there, but then we have more and more things coming here, and which have come here. So Beats is the one that is like directly in working with Elasticsearch, and more new features have been rolled out. So that is one certain thing that I want to tell. So when people started using it, they started with the search, because whenever it started using this platform, when Shai Bannon, our founder who built this product, whenever he started with this, he started with search engine. He thought of doing a receipt search engine for her wife, and then which got into this particular thing called Compass, which is also a GitHub project which is already there, but it's not distributed in large scale, etc. But later he did Elasticsearch, which is like a search engine. And then what happened is search was be the prime thing, and a lot many people use it to use search. For example, GitHub search is Elasticsearch, eBay search is Elasticsearch. You have several Indian startups like Swiggy, Zomato. Everyone uses when you're typing in the search bar, you are doing Elasticsearch. Similarly, like Netflix, help.netflix.com search is Elasticsearch. So there are many use cases where search itself takes away. But then there are other people who are in the DevOps community. There is a person named Jordan who wrote this Logstash, and he started using this logging, and then he pulled that logging logs from different places using the syslog server, etc. And he pulled the data, and he wrote Logstash, and then like he pushed into Elasticsearch, and thereby doing some sort of analytics on top of data. So that is how observability has come in. So which has logs, metrics, trace, APM, like distributed tracing, then uptime or synthetics, many other stuff, which comes under this larger envelope of like observability. And security being very latest and new use case, which is driven by the InfoSec community, wherein there is like all this SIEM, EDR, anti-malware, like your regular McAfee's and CrowdStrike does. They also have use cases like security incident analysis, threat hunting. So all of them come under security. So these are three prime use cases that we see when we talk to people. But then there are other use cases, where developer use cases like business analytics, where people want to do analytics on the data that they have, like product analytics, telemetry, etc. Different sort of ML related applications, supply chain management, etc. So there are many things, but these are the prime things that if I have to tell you what are the use cases of the stack, these are the things. Now, who uses? Like many people use, developers use it, DevOps professionals use it. Then, like I said, security professionals use it, like practitioners, people who does SOC. If you have ever seen the SOC command center in your organization, where there are analysts sitting on and looking at the security data. So SOC commands. There are also like for use cases like APM, the APM or tracing, etc. There are product owners, scrum masters, or people, product managers even. So they want to modify, improve the product, understand what sort of bugs that are coming, how to ensure that engineering productivity is better. So that is another sort of users who use the stack actually. So deploying stack, it's a platform agnostic. As I said, it's an open source project. And then the stack, when I say stack, there are multiple software again, like Elasticsearch is one software, Kibana is different, Logstash, Beats, everything is different. So it is platform agnostic, cloud agnostic, as well as, operating system agnostic. You could also run it in Windows, which very less people do it. Most of them use Linux servers and deploy it on top of it, but most of it is supported, except for very few versions like, PowerPC architecture, which I believe some versions are supported as well, I think. So, but we are not talking about that part of the thing today. But what we are going to talk about, or more specifically mention about, is like, how do you run this particular stack like an orchestration, but like build a cloud service on Kubernetes, like build this stack and the solutions that we speak of till now. How do you build this using a Kubernetes platform? Kubernetes a de facto and undisputed leader of container orchestration. We all know that. So how do we do that? So that's what we are gonna discuss about. So I believe that everyone know about Kubernetes, and if you don't want to cover this particular thing, I would skip that. So how many of you, I mean, like, have known the architecture of Kubernetes, or shall we go ahead and take a brief look about it? Question, people. You can write +1 in the chat. That's easy, rather than if you want to talk about it. Yeah, if you know Kubernetes, write +1. Okay, so what I'll do is, like, because there's less people who are responding to it. So what I'll do is, like, I'll simply go and cover some of these things, and then maybe like we can come back and take more questions if you have. So when I looked at Kubernetes, it's around in 2015 when it started as an open source project in some Google Meetup that somebody was talking about the pod selectors and and many other things. So, and I have literally no idea about how this would revolutionize or change things. And then even I don't know about Docker then in that old times. I only know about LXC containers, that too as a concept, but never thought of using it on my laptop. Never thought that it could be possible as well. So, so then, like, basically, Kubernetes is, like I said, is a container orchestration system, and then you have multiple nodes, and then you have pods which run these containers, and then these pods are deployed in multiple nodes. So that's how you have a distributed system, like different nodes. But also you have internal, again, distributed structure using the pods, etc. Then you have services, which is another decoupled mechanism here, so that through services you could access these pods, maintain, and do a lot of these management around it. Orchestration around it, again, in a declarative way using YAML. We'll talk about that as well. You also have secrets, a secret store. You also have local volumes that you could attach, like you can attach like persistent volumes. There are different stuff like that. You could also attach network assisted storage in that area as well. So that is another useful thing to do it. But then I think around 1.12 or something, Kubernetes has announced something called stateful set, which allows them to run a stateful application, like application which shares states. For example, here Kubernetes itself is a distributed system, and it shares state using some specific thing that we are going to discuss here. But then how come something like, if you take applications which are in distributed systems, like say, be it Redis, or be it Elasticsearch, or be it MongoDB, which is also a clustered application, or Hadoop, they share states, they share information in between their nodes, like between the container to container, they share the information. So how do you ensure that system, that thing is good, and like how do you ensure that all of this happens properly? So stateful set is one great application to that particular thing, and which helps you to do all of this. And then later operator thing also has come, which has simplified it much better. So, like I said, it is a declarative way to do things. You have YAML and you have other resources. People write in YAML. Of course, it's confusing sometimes, indentation issues, etc. But YAML is a great way to define the schema and, like, deploy the applications and run these stuff. I'm not going to spend more time here again. But architecture, like you say, you have a HCD cluster, which is like a key value store. And then you have API server, which manages your entire, the state of this particular Kubernetes by information from kubelets. And then you have the controllers. So you have multiple controllers, which based on that, control logic loop, it will administer what to be done in the next state, etc. So this is the basic architecture. Like, I can go again, but I'll simply skip through. Like etcd is there, API server which does things, user authenticates using HTTP or HTTPS, and then like uses kubectl, which is the CLI tool, or there are many other API based tools as well, like kubrick, etc. If I'm not wrong, there's the interesting tool which helps you to manage this as well. So then you also have kubelet, which runs in this pod like an agent, and then corresponds with the host and does all the stuff. Then the controllers are the things that we are going to dwell upon and then speak about sometime. So there are different controllers already in the Kubernetes, which watches pods, assign them to a node, replication controllers, which make sure that replica set is at a certain amount of time, and cloud provider controllers, like specifically around hardware infrastructure providers. Like say if you are thinking about AWS, they have a specific sort of hardware that you want to deploy, so the controllers which are specific around it. So different controllers does different things. So by this time you might be thinking, okay, I kind of know Kubernetes, and then I will probably be able to deploy applications and do stuff. But I also have DevOps friends who say that Kubernetes is great, but if you deploy on a Friday, I will come and kill you. So don't deploy it on Friday, and things go wrong. I can't manage it, because if you are deploying something complex, if you are changing some things in production system, I can't manage it, and there is no great way to do it. So normal applications, yes, but there are complex applications which help you to which needs more things to be done. And that's also where things like Helm come into picture, wherein it does package management, just like NPM, but more different than for the Kubernetes. It's more complex and different as well. So yeah, so more than Helm, I think operator framework is the one that changed this entire landscape in deploying the stateful applications or running your general purpose applications that you end of the day, all these Redis, MongoDB or Elasticsearch, or you take MySQL, PostgreSQL, or these applications still, but they are general purpose applications. You need a DB, you need a server, right? These are to be run, but there should not be a big problem around running those. These are run-in-the-mill applications. You need to run it safely, easily. So operator framework, the SDK helps you to do this very easily. So yeah, I'll again quickly go through this. So Helm versus operator, one other important discussion that many people might confuse. So Helm is like a package manager. It's in a different level than you compare it with the operator. There are different types of different variations in the Helm explanation as well. But I kind of found this very easy to understand. So if you see here where operator sits in and where Helm sits in, Helm still is in the every other way, and then operator is something below, wherein you still need to work very closely with the Kubernetes controllers and other ecosystem actually. So there is an operator hub site where you can find all these operators for different thing. Of course, you could find the code of whatever the operator that I'm going to talk about here is Elastic Cloud on K8s. There is a reason why we say cloud on K8s. I'll also talk about that as well. Why it is cloud on K8s, why it is not Elasticsearch on K8s, etc. So talking more about it. So we have custom controllers which automate tasks like security, secrets, and several other stuff, like what sort of deployments that you want to do. Suppose if you are looking at logging, if you're a DevOps professional and you're looking at log or in time series data, then you could look at things like different types of tenured policies, like say hot worm architecture, different types of architecture. So that is what we also do call it as deployment templates. You could deploy using the operator with that particular thing. So that's not it. I have the demo. So that's all the important content that we have. But I'll simply quickly go through the demo and then we'll talk. So any questions in between? So if you have any questions like in between, we can definitely talk about it. So please unmute yourself and ask questions, and happy to answer.
Yeah, hi. Yeah, there is one question basically, like, are there any prerequisites to get Elasticsearch up and running, like to configure the cluster or something?
Prerequisite as in?
Like if you're configuring a cluster, like are there some prerequisites on your system that should be there to configure the system, or it's like directly it's a package you can install it in?
Yeah, it's just a package. So that's what I'm going to talk about. That's the operator thing that I'm going to show about. So we haven't touched anything at this point. We didn't go to the site. We didn't download any package. We didn't do anything. So how are we going to deploy it? So if I am not wrong, so let me put it into a different place. And then like you see, I have created, I'll answer this question. Sorry, I didn't get your name, but then I'll answer this question, and then I'll show you something here. And then like we can probably, discuss more about it. So let me quickly connect to the cluster that I have created here in GKE. Okay, so if I click wheel says authorize, yes, obviously, and it will generate and link to my this particular thing. If I say kubectl, I believe this is not visible to some of you. I hope this is visible, right?
Yeah.
Okay. So if you say kubectl pods, I believe it should say that no resources because there's nothing. I think so there is nothing available here. So this is a plain simple vanilla cluster that I have created, and there's nothing here at this point of time. So I have this how to run this. I already have a blog post up and running. I have done this specific thing on AKS, Azure Kubernetes Service. We can simply use the same thing for downloading the application for downloading and running this. I'll just use this to copy my commands so that I don't type mistakes and we waste time on it. So what we're gonna do is here download this this particular YAML file which contains the descriptors and everything to run Elasticsearch. So we are not even giving any email ID, nothing. So it's just simply spinning up a Kubernetes cluster and installing this, and then this will create all these controllers that are there. You could also go and look at the logs that are generated, what sort of controllers, the controller logs that we have just put on, say it shows that waiting to create this operator container, but it might take a while, but hopefully it will come out. So if you see here, we are creating some custom resource definition, a CRD, for called APM server, Elasticsearch, Kibana, and then several other things. Like if you have an enterprise search, even that will come in here. So let me see. Yeah. So now that the container is up, you could see the different controllers that are ready to listen the request from the user in the kubectl, and then take and spin up that particular stuff actually. Yeah. So what we'll do is like we'll spin up the Elasticsearch cluster. So let me see. I am using only one node here. I have 771, which is not the latest version. 791 is the latest version. I'm also adding a load balancer here. I'm adding a load balancer here, which adds an external IP. So I'm just using that as part of it. And I'm also adding some settings like what sort of cluster it is, what is a node type, etc. So let me quickly click on this, and then it will automatically create this particular thing. So when I say custom resource definition in Kubernetes, what is the difference? So you might think like, okay, what is specifically different here? So it is like Kubernetes is now running Elasticsearch like a native component. Like if you see kubectl get Elasticsearch, we are talking to a custom resource definition which in the Kubernetes, which is specifically registered to see Elasticsearch as their own component. So that's why it is driven this way. So let me go and see this. It will take a while to spin up this thing. You can also see that kubectl get pods W, it shows what status it is. It's in the init level. But in the interest of time, I think while this happens, let us also look at the other stuff. So we'll also create a Kibana, and the good thing with this thing is like you'll be able to create an TLS-based encryption, and then between the nodes, and then also you will be able to the cluster is by default secure, and it runs with the security, so you don't need to worry about external access even though you have attached a public IP. So I'm not going to look at the logs, etc. Anyway, you might be knowing it. But like I said, the password is there, so you could get the password from the Kubernetes key store, secret store. Like I said in the previous time, the Kubernetes key store, secret store, which help us to do this, store this credentials like this. Like I have this password generated, the username is Elastic here. So that is the default user that was generated, and then it is stored in the Kubernetes secret store. You could get by using kubectl command, this particular command. What I did is like store in an environment variable that is present in this particular shell that I have. So I After which I could also I could curl this particular thing, and which will show. Let me see if I could curl. But before that, so I have already created a cluster. If you see, it's already running. It also has a public ID. Now, if I want to, I already have the password, which is in the environment variable. I can just copy this external IP. And if I say the version is 7.7.1, and then the different variations. But remember, we have created 7.7.1, but 7.9.2 is the latest version. You can always pull the latest one, and build type is Docker. So basically, we already have docker.elastic.co, where we build all the Docker repos and then push it everywhere in the Docker Hub and everywhere. So if you do Docker pull Elasticsearch, you are pulling a Docker Elasticsearch repo, the container. So what we have done is, like, using the same thing, you have an automation in place called operator, which helps you to do all easily. And there are different operators for even different stacks as well. So it is very popular in the Kubernetes world. So let me quickly deploy Kibana as well. So again, the same version. Remember, your Elasticsearch in Kibana is, if it is in same version, then it gives you, the better access, and it's on the same compatibility features as well. Again, you could do kubectl.get Kibana. Once it is deployed, kubectl get pods. Okay. Okay, it is configured created. Let me run this again on the top so that you will see that. Yeah, it takes a while to create container, but it gets done. And then once you can access this particular, the Kibana dev tools, everything. But with again, by securely logging into this thing. So let me quickly see if it is done. I don't know if it is in watch, but it might be taking a while. So we got the IP. The container has not been created, but let me go and say HTTPS IP, and then I say 5601. It should open Kibana. Okay. Meanwhile, it is not yet because the container is still creating. Yeah, it is running. It should open now. But I also want the password, right? Echo password. So in a minute, we created a cluster which has this particular self-signed certificate, which has the security enabled, which is also running easily. So let me see if I'm doing a mistake here. Okay. 5601. Something is wrong. Maybe it came up, but I kind of 5601. Yeah. So if you see, it shares that your connection is not private and a lot of things. Like I said, we have security. How come this is coming? Because the certificate is self-signed. That's why cert authority invalid. So that's why it's saying it's invalid. But then when you click proceed, it will still show that you need to get in a use Let's Encrypt kind of a thing, and then get some certificate and attach to it. Right now, it is using self-signed certificate. So I could use Elastic and then click on it, and then automatically it will log in. But it didn't happen. Let me use it again. I might have copied the IP. That's why it is not working. Great. So if you see, I have logged into the Kibana. It shows me the getting started experience, like explore on my own, or show it, show the sample data. You could click on try sample data, but then you go to explore on my own, and then you see the home page, and then other stuff here. We'll quickly go to the DevTools part of it, and we'll ingest some data. I hope there is a bit of time. Yeah, so if you have time limits, let me know. I think there's less time, but then if you have anything, like, please ping me on the chat, and I'll take care of it. Like, we can close this much faster. Okay, so what I'm trying to do is, right, I have a data set here, which is national parks data of the US. So what I'm trying to do here is copy this data and create an index, and then we create a search engine here in Kubernetes using Elasticsearch on top of it. So what this data says is it's pretty simple. It's an index named national parks, and then you also have description, location, etc. So when you click yes, it will create the index and everything, and then we can simply go now and use the API to search this data. But what is fun to do that? So we have an open source project again called Search UI, which helps you to do this easily. So let me see if I could spin that up here and then showcase that to you here in a easy manner. So let me come back here. So I have this project here called Search UI, and then which helps us to create this the Search UI just as a friend to do this particular on top of it, and then helps you to create this. So let me cd the Search UI examples Elasticsearch. So you could also like log into this and then to kind of like do that stuff. So it is an npm based project. So you need to install the specific the services or packages that are related to it. There are detailed examples on how to do that specific stuff. So if you click on this particular thing and copy paste this particular stuff, it tries to start like if I say npm start, it will not. It will say that okay, there are errors, but let me see if I could do this for you. Every time it is creating this problem. Okay, so basically what it does is, it spins up a search UI, and it helps you to create a search engine on top of the existing, the Elasticsearch data that we have ingested. So now that we have, now that we have the entire thing that is covered, you could do anything. You could deploy different applications like what do you call APM or search or anything. You could do all of that, and you could run these as services, scale up, scale down, and do all of it. That's why we call it as Elastic Cloud, because we are essentially building an Elasticsearch as a service. So on Kubernetes again. So this is the UI that you would get. So you could follow the same steps that are mentioned in the document here, and then what you could do is like you could build this particular the entire is simple React.js server, and then you could see this data in this manner. So I think we don't have time for doing all of this, but you could go and explore this by yourself. I have links already here so that you could go and look into that. Okay, so that's the end of the session, and I'm happy to take any questions if you have. I know that we rushed through a lot of things, but if you have any questions, happy to ask. And these are the links for the resources for the session. Yeah. Go ahead, Sarvesh.
So the one question is like, can we use this for AI or machine learning as well, like Elastic Stack? Can we use Elastic
I mean,
Stack?
What is the use case? Suppose if you want to do anomaly detection, or if you want to do some sort of data pipelining and then prediction, some predictions using Spark ML, you could do that as well. So there are people who do that in the industry. You could do that out of the box. There is a machine learning mode that helps you to do all of this. Like say if you click here, I'm sorry, okay, double click. So if you see, click here, there is machine learning, and you could do anomaly detection, outlier detection, data frames, prediction, etc. And some things. I'm not saying it is the entire holistic, end-to-end thing. But on the time series data, there are many things here. And on the search side, there are something like query suggestions that you could do. And then on the supply chain and something like prediction of prices for tomorrow or for orders tomorrow, such sort of thing. Recommendation engines for that you could also like kind of use other modules and Elasticsearch as a base and do that. I think there is one such application called GoFood. If you have heard Gojek, they use Elasticsearch for doing predictions and order, how much the person would order the food on the next day, or where is his favorite restaurant to show the favoritism. Even other companies in India are doing something similar. Yeah. So sorry for the long answer, but yeah.
Okay, thank you, Arvind. It was nice to have you here.
Yeah.
Okay, so moving ahead, we have our next speaker. He's Nicholas Frankel. He's a developer advocate with over 15 plus years experience, consulting for many different customers in a wide range of contexts, such as telecom industries, banking, insurance, large retail, and public sector. He usually works on Java and Spring technologies, but with focus interests like rich internet applications, testing, CI/CD, and DevOps. Currently, he is working for Hazelcast, also double as a teacher in universities and higher education schools, a trainer, and triples as a book author. Welcome you, Nicholas. You can have this take.
Thanks. Hi, everybody. Thanks for having me. Thanks to be here for this talk about containerizing application and specifically Java application. I am Nicholas Frankel. Before I was a developer advocate. I was a developer. I was a team lead. I was an architect. Well, I've always worked in technical roles, and I'm very curious right now about the whole stuff about Dockerization and Kubernetes. I currently work for a company called Hazelcast. Hazelcast has two products. Our first product was an in-memory data grid, and you can think about an in-memory data grids as distributed data structures. So if you have like a map or a dictionary or whatever you call it in your language, then it's not limited to your own machine, but it can be distributed all over the network so that the data can be shared or replicated. And the second product is called Hazelcast Jet. It leverages the IMDG in order to do stream processing in memory and again distributed all over the network. We are right now participating in Oktoberfest. So if you want to join us, then we will be more than happy if you can. Containerizing application. So if you want to containerize a Python application, it's quite easy. You just take from the Python 3 or 2 if you are stuck. You get your requirements.txt, you install the dependencies, and then you just add the script, you run the script, you're done. That's super straightforward. If you do the same for a Node.js application, well, that's exactly the same. Perhaps if it's a web application, you expose some ports, but in the end, again, same stuff. You copy the dependency, whatever, you install the dependencies, and you've got everything. The easier part about those scripting languages is there is no intermediate compilation phase. So you just download the dependency, and basically what you see in the script is what will get executed. So it's quite easy. Now, if you are building a Java application, and it can be a .NET application, a Scala application, a Kotlin application, whenever you need to actually compile that, you still need to download the dependencies, obviously, but you first need to have this compile phase that will take, I will talk about Java apps because that's what I'm most familiar about. That takes the .java file and compiles it to a .class file. And in general, you use this to package a specific structure, specific archive, just a zip file, but in the Java world, it's called a jar. And in traditional stacks without containerization, that's what you deploy, that's what you deliver. So some of them can be self-executed, some others can be deployed inside of other containers, such as application servers, but you have those two additional phases. And if I copy paste the script from the scripting language, this is my Docker file. So I will just get from a Maven image. I forgot to copy the sources, and I forgot to copy the pom.xml. So here, just like put them in your head. Then I run the MVN package, and finally I can execute the java.jar. And I assume this is a self-executable jar. This approach works, obviously. It has a couple of issues. The first one is, since we are using a JDK to compile, the final image we also embeds a JDK. That means that first, the image size will be much bigger than expected because a JDK is bigger than just a Java runtime. More importantly, it can compile Java code, and this is a huge security issue. I'm not sure you want in production to have an image that can compile Java code, because I can send it Java code to be compiled that might do some bad stuff on the machine. So you don't want that. Second issue is the version handling. Here I say, okay, it's XYZ because I know that the pom.xml contains XYZ version. So I need to map myself in my head the fact that the POM is of version X and the image will be of version X. There is no automatic version handling. So I could potentially easily have a POM of version X and have an image of version Y. Not great. And finally, there is no layering. That means that I will have a single jar in the final image. And if I need to change a source, all these layers will need to be rebuilt. That is not so great, because sometimes I would just need to change a configuration file or just need to recompile one class. And again, I will need to get all the dependencies. And that's actually what takes the most time, and recompile everything. And that's not super a good idea regarding the velocity of the development. So there is an alternative there. You can create the jar outside of Docker. So let's try to do that. Here, I have my first application here. So I have a simple Spring Boot application. It doesn't do anything really smart. I just connect to an Hazelcast cluster, and then I have a controller, and I have two mappings. The first one puts data into Hazelcast through the client, and the second one gets the list of all clients. Easy peasy. And because I'm super lazy and I don't want to do like bad demos, this is my first try for this talk, so I didn't want to take any risk. So what I did is I recorded everything. So here I show you how I do it. I clean the repository outside of Docker. I package it outside of Docker, and then I build using this Docker file. So basically, this Docker file just takes the jar that has been created outside of Docker and puts it into the container. And afterwards, I just try to use it. I curl, I add one entity, and then I check that everything has been set, and this is the result. And in the end, I just stop the container. So not so great, because every time I need to build something, then actually I need to package it outside of Docker. So the first normal thing would be to do like this. And this is the next step. Actually, I need to do the entire build outside of Docker. This is the result. You've got the same result. Of course, now it takes a bit more time, and I've got everything. Still works. Here I'm packaging without the tests, and I've got my final jar. As I mentioned, you've got a couple of issues. For the record, sorry. I've got a REST endpoint in my Spring in Docker jar. Inside, I have this Hazel class client that does like calls to the Hazel costs stuff. Again, not that great. Here, I embed a JVM, so security issue, no version handling, no automatic version handling, and no layering. Not great. So the next step to get a bit better is at least to use a multi-stage build. So multi-stages builds, they are good because they allow you to have different images regarding your builds. You can have inside your Dockerfile section that is dedicated to building and one that is dedicated to running using this copy -- from. It's pretty widespread. The issue is it's not compatible with Scaffold. So there is still an issue that is open. Scaffold is this automatic checking of changes in your sources that the image gets rebuilt automatically and deployed to a Kubernetes cluster. In general, you do it on your local machine. You use Minikube or K3 or whatever. And every time you do a change, then it gets redeployed automatically. And unfortunately, this is not compatible with Scaffold. However, it works much, much better because at least here, you've got this like GDK that will build the stuff. And then you've got a GRE that will run the container. That makes at least the issue about embedding the GDK non-existent anymore. So here I have my, here I have my Docker images and I have already built everything. And this is version 1.1. So here you can see that if I dive into this one, takes a bit of time, and this unfortunately cannot be prepared beforehand. Here you can see that I'm using a normal, I'm using the normal system. And then if I just show the stuff that has not been modified, I have my GDK. And finally, I have the Spring in Docker.jar. So it's a bit better. And if you want to check, you can also check that here, for example, I have these, I have tagged it. Normally they are not named, but I have tagged it for like checking purposes. You can check the images that was used to actually build the second image. And here you can see that I added the Maven wrapper, that I added this script, that I have added the POM, that I have added the source, and then that I did the package. So it's marginally better. Still, we can do better because now we still have the same issue that before. If we have changes, then basically the layers is just a single jar. So what we want to do is to have a layer multi-stage build so that when we build it, first we get the dependencies and then we've got the sources. So if I change the source, I will still be able to reuse this layer of dependency. Again, let's dive into it. And now we can see all those layers. You still have the same ones. But here you've got the dependency layer, which is 100 megabytes, and the source layers, which is 54 kilobytes. Now imagine that if you don't have this layer stuff, every time you need to change a source, you will reload your dependencies. That's not what you want. So this way, if you change your source, this layer will still be valid. Of course, if you change your dependency, it won't be valid anymore, but that will always be the case. But here, that means that I can just change the source and I will just need to execute the build process. And this will be kept. So it's much, much better. The next problem we want to address is the lack of synchronization between your POM version and your image version. As I mentioned, here I say, hey, Docker build blah, 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 and I need to tag it explicitly because I know that I will be using this jar. But here, if I'm changing, if I'm like making a typo, I can type 1.3, 1.4, 2.0, whatever, and it can get me the wrong version, the wrong tag on my Docker image. The next step, the alternative, is to use something called Jib. And Jib is actually a Maven plugin that you just put into your POM. And by default, it's able to push to a remote Docker repository or to your local Docker daemon. You've got a lot of configuration options. For example, you can choose your parent image. And it's smart because it doesn't try to run the job. I mean, think about it. If you are not in a container world, your jar is the unit of deployment. So it needs to be a single archive. Once you've got the container, your container becomes the unit of deployment. And in that case, what's inside, whether it's a single jar or it's exploding in classes and resources and whatever, it's not that important. So this is a very, very good idea, actually. So the benefits is there are no Docker files. It's an automatic version handling from the POM. And you've got 3 layers. You've got the dependency layers, you've got the resources layers, and you've got the compile code layer. So again, it does it for you automatically. Let's see how it works. I will dive into the Spring Boot 2.0, which is the Jib one. And as you can see, it's from Google. They are using Bazel. And here you can see the layering of Jib. So the first layer is actually the libs. The second layer is the snapshots. The third one is the resources. And the final one is my code. So if I change my code, I will keep my resources. If I change my resources, I will the libs. So I think that at this point, we are very happy and we could stop there. But actually, let's talk a bit about the snapshots. We are using a Spring Boot application. Let's try to use this layer-aware multi-stage builds for ourselves. And we will do manually what Jib did for us. So basically, the layers will be, again, the same one, but it will be a different order. It will be first the dependencies, and then the resources, and then the snapshot dependencies, and then the compile code. And the reason for that is that snapshot dependencies, they might change every time. I mean, perhaps you are not aware of that, but snapshots dependencies are just like they have a tag, but the content it can change anytime. So they are very unstable. You should never deploy something with snapshot dependencies, but here it's for the sake of the argument. And also when you are developing, it might be the case that you are using snapshot dependencies. So how does it work? here I have a Docker file again, and you can see that I kept the dependency stuff in a single image. And now when I'm building, I'm trying to be smart. So basically I'm using a GRE to copy the jar from my previous builds. And then I'm using the Spring Boot feature that is able to take this jar and explode it again into different layers. And then on the final step, I just add all those dependencies by myself in the order that I want, and I get the result. So let's dive into it again, and it should be called 3.0. Here, I've got the dependencies that I wanted and in the order that I wanted. So here, my sources, here, Spring Boot itself, here, the snapshot dependency, and here, the dependencies. The good thing about is that I can change the order. Like for whatever reason, I know that, I don't know, that the snapshots will be changing very often. I can put it in a top dependent. Well, here it would be the bottom, but it will be a top dependency, top layer. So it's not an issue if I discard it very often. It's up to you. You can also do your own layering. It depends on what you want to do. Here, for example, you have this layer.edx. It's a configuration file, and you can do whatever you want. And if you check Docker images grep Spring, you can see the builds, because here I have like one build and the second build image, and I've referenced them as 3.0a and 3.0b. So let's check how it works. I mean, this one is the most important one. It's dive 3.0b. And you see here that it starts from having a jar and it explodes it into different places. And then the next step is to get those places and to say, hey, here I will put them into the final image with those layers. Great, that's a bit better. But we get back to Docker files. That's what I mean, again, we've got this problem of synchronization. I need to know which version I'm containerizing, so I'm not super happy about that. Another alternative is to use build packs. Perhaps you've heard about build packs. Build packs, you just say, hey, I want to use this build pack, and it gives you a general idea, like it might be a Java build pack. And then the Java build pack will like sniff your project, and it will understand by itself which builders it will need to invoke. So it will say, this as a pom.xml file, it must be a Maven project. Or, oh, it has a Gradle build file, so it must be a Gradle project. And I will respectively invoke the Maven builder or the Gradle builder. They are based on an old idea of Heroku. I don't know if you have ever used Heroku, but basically you could upload your sources to a Git repository on Heroku, and the Heroku platform will like sniff this stuff and will build the correct package and deploy it. It was quite interesting, and now it is backed by the CNCF. So Heroku and VMware, they are at the lead of this initiative, and it's a CNCF project. So there are a lot of configuration options, the main one being the builder. Good things is you've got no Docker file, it's Docker friendly, and you've got the previous 4 layers. So, I mean, it could be the final solution. Still, there are some downsides. So basically, again, you've got no version handling automatic. So you need to think about the correct version. Something very important with Jib and with the Docker file, you can choose the parent image. Here, the parent image is chosen for you. So it can be a huge image that you don't need to. It can be a huge image that has like a bigger, a wider attack surface. Not super great. What I've also noticed is that even if you had no changes, the process will run every time and it can take a while. The reason for that is that it seems as of now, the image that are used during the build, they are not cached. So basically every time it will need to download the GDK. Worst, that I didn't write because I was a bit ashamed. I still tried yesterday. I used a specific builder. It was a tagged version 0.3. And basically like 1 week ago, it worked. And this week I tried it again and it didn't work anymore. So basically the tag means that it's not immutable. They are changing the stuff meanwhile. And I believe that's really, really, really bad. Let's try, because I just want to have fun. It's called, yes, something like that. And I just want to show you, I mean, so here it will probably fail because it tells me that the image are up to date. But here you see that I'm using no snapshot dependency. I'm using the 0.3 and they change it meanwhile. So here what is interesting is they are checking that actually what is my project. And it says, oh, it's a Maven. Oh, it will run in Apache Tomcat. Oh, there is a Spring Boot project, this kind of stuff. And of course here it tells about the GDK. So I believe that's very interesting way to go if it works. Right now for me, it's not stable, completely not stable. The next stuff will be about the CLI itself. Sorry, the build pack. So the final solution is to use the Spring Boot Maven plugin. So instead of having an external command line, this pack command, you have a dedicated call from the Maven lifecycle. And you've got, again, a lot of configuration options. And I think that's quite good because you've got no Docker file to handle. It's layered. The POM and the Docker image version are in sync because it's inside of Maven. That's pretty cool. But you have no choice of the parent image. And how does it look like? It looks pretty impressive, actually. As you can see, there is no Docker file anymore. And the POM, I just needed to add the latest Spring Boot. So basically, I'm using a version of Spring Boot that is not released yet. And if I run it now, so again, I did that yesterday because I don't want to run into demo issues. Play its version 4. Nope. Nope. NS, no, it's version 50 then. So I just need to invoke this build image stuff, and it's all it does. And again, you can see that here it does the same. So it pulls the same pack file and it checks. Like here, for example, I change it to use GraalVM. So it tells me, hey, I will use GraalVM, I will use an executable jar, I will use Spring Boot, I will use Spring Boot native image. And then you've got the same stuff. Very important, it takes ages because here I'm I'm doing it for GraalVM. So if you compile for GraalVM, you are taking the jar and the bytecode, you transform it to a native. And finally, well, it takes a long time. But actually, it works and it's very configurable. You might think that flattening the layers just before deployment might be a good idea. I've checked, I've used something called Docker Squash. So basically, you like get the Docker image, you get it into a tar, and you create a Docker image out of it again. So you remove all layers. For the version 1.0, so the first version that I showed you, I've got a very marginal gain. And on this last one, I've got less than 1% of gain in size. So I'm not sure flattening layers is a really great idea. But I mean, it depends on your issues, but it's just like a wrong good idea. So in this talk, I try to address some issues that you have when containerizing your Java apps. The one is how do you sync your version between the POM and the image? How do you organize your layers for faster developments? And I try to show you that Squash is not super useful in the end. Here, these are the final. So here you see I have a Go issue when I'm trying to use the build pack with the CLI. Not great, not a good idea. Docker images, grep Spring. So this is my 5.0, which has been squashed. And actually, as you can see, it's 182. And the 5.0 that has not been squashed is 184. So not great, not super huge advantage. However, from going to a normal jar to a native executable, it goes from like 260 megs to 180 megs. So that's quite interesting. So if you want to have a slim image, then I would encourage you to do the GraalVM stuff instead. Okay, this is all, folks. Thanks for your attention. You can read my blog where I publish weekly blog posts. You can follow me on Twitter. And interestingly, you can also check the code repo that I've just showed you so that you can do everything on your own machine. And now perhaps there are some questions.
Yeah. Yeah, I'm audible. Hello.
Are there any questions?
Yeah, I'm audible. Nicholas, am I audible?
Sorry?
Am I audible?
Yes, you are audible.
Okay. So the first question is, is increasing the memory and letting the JVM set its own parameters is not always a good idea while we run Docker container.
That's a good point. Yeah, the GVM is great when you have long-running processes, and then the GVM can adapt itself to the workload. So that's generally a good idea when you are long-running processes. The thing is, when you are running inside of containers, in general, it's because you want to kill them every now and then. And so then the benefit of the GVM is not that good. However, what I showed you in the last example, you can use GraalVM. And basically, in the GraalVM world, then you've got a native executable again. And then you've got very fast startup time and low memory consumption. So you can still develop in Java and have all your tools and have the benefits of the containerized world.
Okay. The other is, if I'm new to multi-stage build, do you think multi-stage build would work for Java?
Sorry, could you please repeat the question? I'm not sure I understood.
Like if I'm new to multi-stage builds, So do you think that it will work for Java, like multi-stage builds can work for Java?
It needs, I mean, in Java, you at least need multi-stages builds. Again, if you don't use multi-stages builds, that means that you will run a container that contains a GDK that will be able to compile Java code. It's not a great idea to have something that can compile in production. So you will need to use multi-stages build to have a GRE.
Okay. The third is, when you run Java applications in Kubernetes, how does one pass environmental variables for JVM or Java?
There are multiple, it depends. Well, the answer is it depends. For example, if you are using Kubernetes, you can have this env variable and Java OPTS. In general, since I'm using Spring Boot, you don't need to always pass environment variables. You can also have like parameters on the command line. So it still works also very well. So you need to be aware that some stacks such as Spring Boot, they allow you not to use environment variables, which is always better. And my cat is like coming on my chair. So sorry, I need to say hello to my cat.
Hello.
Other questions?
Yeah, the last one is, if I'm using Docker Desktop for my Mac, do I need to consider any settings for JVM to operate smoothly on my MacBook?
If you have enough memory and if you have enough CPUs, which is my case, I'm using Mac, I'm using Docker for desktop. I have no issues regarding the JVM. I mean, you just need to have enough resources, but I believe it's more a problem of hardware than of software configuration.
Okay. Thank you, Nicholas.
Thanks. Thanks for having me, and yeah, have a good day.
Okay, thank you. Okay, moving to the end. It was great for everyone to be here to attend the OSCONF. Okay, so I'd like to thank each and every member who has participated and who has worked hard through days to just bring this event happen, to make this event happen. And I'd like to congratulate them. It's finally done. Their hard work has paid off. And I'd like to thank all the speakers for making our day wonderful with all the knowledge they have showered us with today. More importantly, in future, if you want to connect with us, or if you want to, be part of OSCONF that are coming, you can always subscribe us, or you can always link us with, you can join our community over Slack. I'll be sharing links as well. And all these slides and all the presentations and all the talks will be available to you over the GitHub repository. And to contribute, you can always go to the links over here. So in the end, I'd like to thank all of you again. Have a good day. Ajit, do you want to say something?
I think we are good. Thank you everyone for joining, and definitely we will be coming up with more exciting talks, and then let's wait for the next OSCONF. If you want to be part of the OSCONF, if you think like you have a group where you can go ahead and collaborate with us, definitely do reach out to us. So I would like to thank each one of you, especially the organizing team who has put a lot of effort in making this happen. Thank you and have a great evening.
Thank you.